Good morning. Good morning, everyone. My name is Ala Kamil, and I am serving as the designated federal official to the U.S. EPA Science Advisory Committee on Chemicals, SACC. For this meeting and in my role, I will be opening the second day of the public meeting on the Science Advisory Committee on Chemicals review of EPA's draft risk evaluations for dibutyl phthalates, DBP, dicyclohexyl phthalates, DCHP, and di-2-ethylhexyl phthalates, DEHP, and the technical support documents for butylbenzyl phthalates, BBP, and diisobutyl phthalates, DIBP, and the cross-phthalate human health benchmark dose, BMD, analysis, cancer analysis, and cumulative risk assessment technical support documents. I'd like to repeat that the SACC meetings are subject to all FACA requirements. These include open meetings, timely public notice of meetings, and document availability to the public. All documents are available to the public in the docket at regulations.gov. As a reminder, this meeting is being webcasted, transcribed, and recorded. A live stream of today's meeting is available on YouTube, and you can access the link on the meeting website, which also has links to the meetings we had in the previous day. I would like to thank Dr. George Cobb and Dr. Robin Ann Gentry for facilitating the sessions yesterday, and I would also want to thank the committee members and ad hoc reviewers. And now I hand it over to Dr. George Cobb. Dr. Cobb.
Thank you, Dr. Kamel. Let's go ahead and take the roll for the morning. Start with Dr. Chasen.
Good morning. I'm here. Thank you.
Dr. Ike.
Good morning.
Dr. Fong.
Good morning. I'm here. Thank you.
Dr. Fox.
Oh, I'm here.
Hi. Dr. Gentry.
Good morning.
Dr. Graham.
Morning.
Dr. Heiger Bernays. Ms. Jenkins.
I'm here. Good morning.
Dr. Lee.
I'm here. Morning.
Dr. Merced Nieves.
Good morning, here.
Dr. Ottinger.
Good morning.
Dr. Semmel.
Yes, good morning. I'm here.
Dr. Babbage.
I'm here.
Dr. Chang.
Right here.
Thank you. Dr. David.
Yes, I'm here. Thank you.
Dr. Fanning.
Here. Thank you.
Dr. Martinez.
Present. I'm here. Good morning.
Dr. Rollins.
Here.
Dr. Spade.
Here. Good morning.
And Dr. Wolf.
I'm present today.
Glad to have you here today. Let me circle back. Did Dr. Heiger Bernays join? She was going to be out for a little bit today. Okay. Thanks for going through that with us. Now, as we do or try to do every day, we'll circle back for clarifying questions that the committee may have for the agency or for EPA. I don't see any hands raised. And EPA, do you have any clarifications from any of the discussions that we had yesterday that you'd like to relay to us?
This is Anthony Lowe's with EPA. We don't have any questions for the committee based on yesterday's meeting.
Okay, thank you very much. Okay, well, we can move into the business of the day on the agenda, which is the physical and chemical fate and transport technical support documents for DBP, DCHP, and DEHP. And we'll hear from EPA on charge question 1, and I'm sorry, I do not have listed who's the presenter. So EPA, please proceed.
Thanks, Dr. Cobb. This is Anthony Luz with EPA. You can go to the next slide, please. All right, now I'll read the first charge question into the record, and this is on physical chemistry and Phtalates. So charge question 1, for DCHP, EPA relied on data from several sources to derive water solubility estimates, as described in section 2.4.8 of the draft physical chemistry, fate, and transport assessment for DCHP. EPA is requesting feedback on the weight of scientific evidence approach describing the water solubility range for DCHP and the use of a single value as input to exposure models.
All right, great. Thank you. And now we have our discussant group, and our lead discussant for this question is Dr. Lee. Dr. Lee, please proceed.
Okay, good morning, everybody. So this is Lee speaking, SACC member, University of Nevada, Reno. So I'm now sharing the comments on the first charge question. So first, SACC commends the EPA's effort to search for and combine various source of measured and predicted data to identify values that are best represent the key chemical properties. Can you hear me? Okay.
Yes, we can
right.
hear you.
Yeah. However, SACC has identified 3 major concerns with the EPA's general process for data collection, evaluation, and consolidation. And second, the SACC also appreciates EPA's use of a weight of evidence approach, especially in presenting a range of values for the properties such as water solubility. However, the SACC also emphasized the importance of testing and the sensitivity of exposure estimates to the selected property values. When a parameter's variability leads to substantial differences in exposure outcomes, the EPA should adopt the most health protective realistic value available until more precise real-world measurements are obtained. This precautionary approach helps ensure the public health remains adequately protected in the face of scientific uncertainty. So now I will read the specific comments into record. So first, record comments on the major concerns with EPA's general processes for data collection, evaluation, and consolidation. Number 1, there is a lack of transparent justification and verification for data selection. Specifically, although the EPA lists a range of collected values, it doesn't provide a detailed justification for why certain numbers were included, but others were excluded. The SACC identifies a number of examples throughout the review. Although the following examples reference DCHP based on the draft physical chemistry, fate, and transport assessment for DCHP report, similar issues are evident in assessment for other phthalates as well. Example 1, in evaluating vapor pressure of DCHP, the EPA cited a value from the NLM database. If we take a closer look at the source, we can find that the number actually originated from a paper published in 1950s. In fact, that paper did not directly measure the vapor pressure at 25 Celsius degree. Instead, it measured vapor pressures at a different temperature, much higher than 25 degree, from 120 degree to 225 degree, and extrapolated the numbers to 25 degree using an empirical equation. In contrast, A more recent 2015 study also reported another value using a similar experimental approach, but with the important distinction that it included the direct measurement at 25 Celsius degree. EPA cited this more recent number, but for some unknown reason, excluded this number from the final estimate without any explanation. Example 2. In evaluating the water solubility for DCHP, the EPA used two EPI switch modules, but disregarded the higher water NT value, 2.4 milligram per liter and 4 milligram per liter estimates. Although dismissing the highest value may be defensible, excluding the 2.4 milligram per liter value lacks justification. Example 3. In deriving KOW for DCHP, the EPA showed a clear preference for the values reported in the ECHC assessment, but rated alternative data sources as, quote, median quality, quote, and excluded. However, the rationale for assigning higher certainty to the ECHC value was not clearly explained or justified. Example 4. In evaluating the Henry's law constant for DCHP, the EPA mentioned that the experimental value 1.1 times 10 to the negative 7 was included in the EPI suite database, but excluded this value because, quote, the source for this value was not able to be identified for review and no further context was provided by the EPI suite, quote. This is not appropriate because all experimental values in EPI suite were from the PhysiPro database developed and curated by the EPA. Without any other indication to the contrary, this unknown source must be directed result of data. So number 2, there is a lack of systematic quality review of data source. The SACC comments that the EPA evaluates and rated data quality across 3 domains and acknowledges some aspects like reliability unbiased and reliability analytical method within the test method. However, it seems that limited attention was given to critically assessing whether the test method can really produce reliable measurements. The reliability of the data points depends heavily on the appropriateness of the measurement method and its applicability to the specific chemical. For example, in terms of water solubility of phthalates, the SACC noticed that many reported values are derived using the shake flask method, followed by centrifugation. However, this method is known to be unreliable for phthalates. This is because these compounds have high hydrophobicity and viscosity, and the vigorous shaking can result in the formation of suspensions or emulsions rather than true aqueous solution. In the meantime, centrifugation is not effective at removing emulsified droplets of phthalates, as their specific gravity is close to that of water. So, such methods tend to overestimate true water solubility. This issue was not brought into attention in academia until the early 1990s. This is why measurements using this method before 1990s may not be reliable, even if they follow the recommendation procedure at that time. An example is the Howard et al. 1985 measurement for DBP, which state that its protocol, quote, was designed to meet or exceed the requirements of the EPA recommended procedure stated in the U.S. Environmental Protection Agency 1979, quote ends. However, by today's standards, this method should no longer be considered reliable. Despite this, when evaluating DBP water solubility, the EPA stated that, quote, extracted and evaluated 12 high-quality data source cause ends, and eventually selected, quote, a water solubility of 11.2, Howard, 1985, as the empirical value obtained from the overall high-quality data sources that best represent DBP's mean water solubility under standard environmental condition. Quote ends. Unfortunately, many of these so-called high-quality sources, even including the selected Howard et al. Measurement, use the shake flask method with centrifugation, which therefore makes the derived value problematic. Moreover, in some cases, such as water solubility of DBP and DIBP, all collected data were considered equally valid, regardless of the methodology rigor and the data quality. The EPA simply calculated the mean of all available values and then select one measurement that is closest to this mean value as the representative value. This is problematic as the mean can be biased by flawed or low quality measurements, and the close to mean value may also be flawed or low quality measurement. That said, the SACC calls for a more thorough review of the data quality should not be interpreted as a recommendation to exclude all data rated as low or medium quality and rely on only high quality data. This is especially important when doing so would result in an insufficient data set. Low quality data points should only be excluded if the remaining data sets is sufficient and robust. For example, in data sets with fewer than a certain number, for example, 6 measurement values, lower quality measurement may still be considered, but within a lower weighting in computations. In addition, this comment should not be taken to imply that the SACC inherently prefers newer data over older data, or that no risk assessment should be done in absence of high quality data. Rather, the goal is to ensure transparency and scientific rigor in evaluating and using available data. And number 3, the EPA only evaluated physical chemical property data individually, seem not to have considered consistency across multiple property data as a whole. When looking at a single property, for example, water solubility or vapor pressure at a time, with several experimental or predicted value available, it can be difficult to determine which value is more reasonable in isolation. But by looking at multiple property numbers together and considering the thermodynamic relationship among them, it's sometimes possible to assess the possibility of specific numbers more effectively. For example, based on thermodynamic triangular relationship in physical chemistry, there are 2 independent ways to calculate the Henry's law constant for DBP. If we use the number selected and recommended by the EPA, for example, in Table 2 of draft physicochemical fate and transport assessment for DBP, number 1, if the first one is to express the KAW as KOW divided by KOA, and then express the Henry's law constant as KAW times ideal gas constant and the temperature. If we go this way, we would get 0.0096 for the Henry's law constant. The second one is to express the Henry's law constant as vapor pressure divided by the water solubility. If we go this way, we would get a number 0.0259. These 2 Henry's law constant estimates differ by a factor of 2.7. This means that selected and recommended values of one or more properties could be uncertain. To address this, the EPA may wish to either apply a thermodynamic adjustment to harmonize the gap, or revisit and re-evaluate the selected input values to ensure internal consistency. And the following would be the comments on the use of weight of evidence approach for DCHP water solubility data. The SACC appreciates the EPA's weight of evidence approach, and it does not simply repeat the water solubility value of 4 milligram per liter that is used in many resources. The SACC reached a consensus that relying on a single water solubility value in the fate and exposure assessment is not always adequately justified, especially when multiple data points and sources of uncertainty are available. The SACC has also consistently recommended that EPA evaluate and report a range of possible values for each property through a sensitivity analysis. This analysis would assess whether different values significantly impact exposure outcomes. For properties where a range of values had minimum effect on exposure results, a single estimate, whether either midpoint or more health protective value may be appropriate. However, when a parameter's range leads to substantial variation in exposure estimates, the EPA should adopt a realistic health protective value until more precise real-world measurements can refine the estimate. Here, by realistic, the SACC means the property value should be reasonable. By health protective, the SACC means selecting the upper or lower bounds of the chemical property values that are more likely to overestimate rather than underestimate the risk. The SACC also agrees that a surface water concentration or more precise solubility data are needed to refine the estimates. However, there are divergent views on the appropriate range for water solubility in this sensitivity analysis. 3 SACC members support the use of a range between 0.03, and 1.01. Given that the lower bound has been cited in multiple sources, but the higher bound was derived following the OECD guideline 105. It should be noted that the value of 1.01 milligram per liter originates from the EPA's registration dossier for DCHP, where it was initially reported as 1.015 milligram per liter. This value was later rounded to 1.01 in Appendix A, Table A1 of the EC, Environmental Canada and Health Canada 2017 document cited by EPA. The EPA correctly cited this number in its systematic review support document for the draft risk evaluation for DCHP document. But the EPA seemed to have incorrectly cited this number as 1.04 in the main report and repeatedly used this wrong number throughout the main report. 2 SACC numbers do not support use the 0.03 number. Among them, one SACC number argued that, number one, this value is not a measured water solubility and instead is the lowest concentration level tested in a 2016 toxic test. And number two, it was measured in water with 0.82% DMSO. However, if we check the 2016 study, there is no explicit indication that a DCHP precipitates at this concentration if no DMSO is added. In addition, the REACH regulatory document lists a measured water solubility of 1 milligram per liter and modeled values of 0.62 and 0.04. The mention of DCHP's low water solubility is just a footnote, not a tabulated result. One SACC number noted that DCHP water solubility is likely greater than 0.03 milligram per liter, based on the inference from other property data. Specifically, given that EPA had high confidence in the Henry's law constant value of 9.446 times 10 to the negative eighth, one can estimate the water solubility using the relationship of Henry's law constant divided by vapor pressure divided by water solubility. If the EPA choose to retain the 1950 estimate from the vapor pressure, then a water solubility approximately 4 milligram per liter would yield the best agreement between the selected Henry's law constant value. Alternatively, if the EPA choose to use the more recent 2014 vapor pressure estimate, then a water solubility about 2.8 milligram per liter would yield the best agreement with the selected Henry's law constant value. This value is at the same order of magnitude as 1.84A or 2.4 mentioned in the report, higher than 0.03 value. And the SACC also has some additional concerns. There are several serious problems with the draft physical chemical fate and transport assessment for DCHP. Number one, in the summary section, the EPA wrote that DCHP, quote, will remain exclusively in soil when released into the soil. Quote ends. This is not true. Number two, in the summary section, quote, the EPA wrote that DCHP, quote, is not expected to move up the food chain in aquatic environment, quote end, which is not true. It's more likely that DCHP will not have magnified up the food chain. Magnification is different from accumulating or moving. This is an essential aspect of environmental chemistry and exposure assessment. Fish that consume invertebrates are likely to obtain DCHP and other phthalates from ingestion of the invertebrates. Additionally, there is no consideration of the properties of the first hydrolytical transformation products of DCHP, monocyclohexylphthalate. Number three, in section 1 introduction, the EPA wrote, quote, DCHP has been categorized as the non-volatile organic compounds, quote end, and then cite the Environmental Canada, Health Canada assessment report to back up this statement. This is inappropriate. The Environmental Health Canada assessment report did not classify DCHP as a non-volatile organic compounds. That report lacked any volatility-based definition for phthalates. Instead, it used the word semi-volatile to describe the analytical method applied to the phthalates class. Regardless of data source, a semi-volatile chemical can be defined as having a vapor pressure range from 0.01 to 10 to the negative 8 kilopascal, or a boiling point between 250 and 370 Celsius degree. The boiling point criteria is less reliable due to potential thermal decomposition during heating. Non-volatile compounds cannot be analyzed through gas chromatography, but DCHP is quantifiable using this method, as shown in Gore et al. 2013, which studied phthalates near Xi'an, China. The US EPA approved the method A270E for semi-volatile organic compounds in hazard waste include phthalates with C1 to C8 ester groups. Table 2.2 report a vapor pressure of 8.69 times to the negative 7 millimeter mercury, which the EPA deemed high quality. Although this value falls at the low end of semi-volatile range, DCHP remains semi-volatile, not non-volatile. Given that EPA has determined the Henry's law constant value that is possible, we can estimate a vapor pressure using the relationship Henry's law constant is the vapor pressure divided by water solubility. If the EPA used a water solubility of 1.48, this yields an estimated vapor pressure of 4.2 times 10 to the negative 10th. Alternatively, if the EPA used a water solubility of 4 microgram per liter, this yields an estimated vapor pressure of 1.15 times 10 to the negative 9. In any cases, classifying DCHP or more volatile phthalates as non-volatile is inaccurate. Number 4, in section 3.4.1, the EPA admit that all data from outside the US and Canada. The SACC did previously challenge the use of data from outside the US and recommended gathering the needed data through the EPA efforts from manufacturers or trade association. However, that previous recommendation should not be interpreted as eliminating the data from outside the US while also failing to obtain the needed data. If there is not a robust data set of quantified concentrations, then the concentration outside the US might also be tabulated. In addition, the existing aqueous phthalates concentration data need to be reported in the body of the text, not buried in a table within Appendix B3. The simple fact is that the EPA must either obtain measured concentration of DCHP near likely released points and report those data and the method transparently, or assume near worst case scenarios in water and other environmental media. So based on the above statement, the SACC has the following recommendations. Number 1, EPA should provide a detailed justification for selecting or excluding property data and clearly document the rationale for prioritizing some numbers over alternative values. Number 2, the EPA should conduct a systematic quality review of data source, especially for water solubility data, with careful consideration of the appropriateness and the applicability of the test method, exclude inappropriate estimate, and make a decision based on the highest quality data available. Number 3, the EPA should perform a sensitivity analysis using a water solubility range of 0.03 to 4 milligram per liter for DCHP in exposure models to assess the impact on exposure outcomes and avoid reliance on a single inadequately justified value. Number 4, the EPA should evaluate DCHP's water solubility in conjunction with related properties, for example, vapor pressure, Henry's law constant, using thermodynamic relationships. Number 5, the EPA should correct the scientifically incorrect language about volatility, trophic transport, and the partitioning behavior. Number 6, in the absence robust measured phthalates concentration in US waters, EPA must include measured water quality data from other countries. Number 7, the EPA should correct the cited value of 1.04 to 1.01 consistent with the original data from the EPA registration document and the Environmental Canada and Health Canada 2017 report. And finally, the SACC provided the following minor comments. Number 1, as a comparison, the draft chemistry, fate, and transport and assessments for BBP, section 2.2.6, water solubility, provides the use of water solubility. It would be helpful to repeat that information in the DCHP document. From the DPP document, water solubility is used in understanding fate and transport of BBP in the environment. but also when modeling for industrial processes, engineering, human and ecological hazard, and exposure assessment. Number 2, Section 2.4.8 of the Draft Physical-Chemical Fate and Transport Assessment for DCHP report sets, quote, co-solvation such as that demonstrate in the whole field may follow the entry of phthalates into surface water and groundwater at otherwise achievable concentrations, quote ends. Since the water solubility of 4.0 is not used based on justification from the EPA, the SACC questions whether this sentence is appropriate for this session. And if the EPA determines so, it should be clarified. Also, the word achievable seems to be unachievable based on the sentence meaning. And number 3, Section 2.4.8 of the Draft Physical-Chemical Fate Transport Assessment Documents for DCHP report states, quote, the true solubility of DCHP may be lower than the 1.48, with concentrations in the environment expected to be lower based on environmental monitoring data, quote ends. However, no such, quote, environmental monitoring data were included in the SACC review package. Number 4, in section 3.4.2.1, the EPA wrote that DCHP, quote, may be released into surface water from TSCA COUs, but is generally released in low quantities, quote ends. It then points to the environmental release document, which, however, does not contain such data related to release. Number 5, properties such as the flash point, viscosity, and the refractive index are irrelevant to this review and should be consolidated into a brief section. So that's everything about the comments on charged question 1. So thank you. Do we have any other additional or extra comments from the SACC?
This is Cynthia Graham. I was one of the discussants and my comments have been included.
Thank you.
Hi, Allison Jenkins. My comments were included. Thank you.
Thank you.
Wendy Heiger Bernays. My comments were included. Thank you.
Thank you.
Dr. Cobb, he had a fire drill. I'm not sure if he's back or not. So if he's not back, maybe Dr. Gentry, you can facilitate this session.
Okay. So, do we have, it sounds like that you've included all of the comments from the discussants in this group. I think we've heard from everyone except Dr. Fong.
Yes, thank you very much. Comments included.
Okay. Are there any other comments from anyone else on the committee? Questions or comments? Okay, I think, Dr. Kamal, I turn it over to EPA to see if they have any clarifying questions.
Anthony with EPA. First, just like to thank the committee for their detailed and thoughtful response to the first charge question. We don't have any questions or need for clarifications at this time.
Okay. All right. If there are no additional comments, I guess we would move on to charge question 2.
Thank you.
Thank you. And then I guess EPA will lead us through the charge question.
Morning, this is Christopher Green with the EPA. I'll be reading charge question number 2. An ecological hazard characterization described in sections 4 and 5.1 of the draft environmental hazard assessment for DEHP. EPA determined the avian hazard value based on an egg injection study employing a single dose, resulting in a lowest observable adverse effect level, LOEL, of 100 milligrams per kilogram. Study Abu Ghani 2012. This LOEL was based on a behavioral change, a decrease in imprinting preference scores in the newly hatched chicks, 14 to 24 hours old. For the risk characterization, EPA determined risk by comparing the avian hazard value to exposure levels in eggs from monitoring studies. Specifically, Schwartz et al. 2016 collected samples from failed peregrine falcon, Falco peregrinus, eggs within Germany as part of a large survey of pollutants. Concentrations of DEHP within peregrine falcon eggs were reported as, quote, traces of DEHP, end quote, with no quantitative concentration values. Limit of detection, LOD, equals 0.001 milligrams per kilogram dry weight. A more comprehensive study on environmental pollutants within egg samples was conducted on seabird species within coastal Norway. Huber et al. 2015. Concentrations of DEHP of 0.011 to 0.024 milligrams per kilogram wet weight for the European herring gull, Larus argentinus, and 0.003 to 0.042 milligrams per kilogram wet weight for the European shag, Phelocrocarus aristolis, were reported in pooled egg samples from Huber 2015. These measured phthalate concentrations found in the wild bird populations are 4 orders of magnitude lower than that used in laboratory-administered injection treatment of 100 milligrams per kilogram DEHP in chicken eggs, Abu Ghani 2012. Please comment on the strengths and uncertainties of this avian hazard value, including relevance and proposed screening approach for quantitative risk characterization.
Okay, thank you. And now I will turn it over to Dr. Ottinger, who is our lead discussant for the SACC.
Thank you. Can you hear me all right?
Yes.
Okay, thank you. I'd like to thank the discussants and others for providing excellent input, and I'll now read our response. The issue identification, the study by Abdul Ghani and colleagues in 2012 serves as the basis for an avian hazard threshold. The 100 milligram per kilogram LOEL is based on a single dose egg injection study in the domestic chicken, Gallus domesticus, with imprinting behavior as the measured responsive endpoint. Is this screening approach appropriate and sufficient for quantitative risk characterization? The scientific rationale goes as follows. There are significant uncertainties in this estimate, which essentially amounts to a LOEL derived from a single dose in a single study. That there are areas for improvement. In the analysis of the Abdul Ghani data, the EPA report correctly states that on lines 365 to 366, there was no significant difference in hatching or late hatching at any treatment level. However, EPA states on lines 366 to 368 that DBT and DEHP data were pooled for statistical analysis, making the hatching and developmental defect data unsuitable for derivation of a POD for DEHP. Table 1 of Abdul Ghani et al. Shows separate values for control, DHP at 520, 50, and 100 milligram per kilogram per day, and DBT 100 milligram per kilogram. but the DBT group was included in the same chi-square analysis as the DEHP groups. Table 1 reports a significant difference in the defects in birds that hatched between control and pool phthalate treatments. There are no pairwise statistical comparisons between groups, possibly because the control value is 0, but the defect rates are 0, 0, 13, 15, and 33% for the 0, 5, 20, 50, and 100 milligram per kilogram groups, respectively. The 100 milligram per kilogram DBT exposure resulted in 13% rate of defects. The inclusion of the DBT group in that analysis is not best statistical practice, but it is not likely that it was the sole driver of the significance of the pooled chi-square analysis. Even without clear statistical analysis, this suggests a significant increase in developmental defects between 5 and 20 milligrams per kilogram per day. However, the raw data can be inferred from the total hatched embryo day number and percent with defects reported in Table 1, which would enable new statistical analysis. Taken together, these data support a low L of 20 milligrams per kilogram day, or as summarized below in our following discussion, below 10 milligrams per kilogram day. It should be noted that EPA's Ecotox database does identify 5 milligrams per kilogram as a NOAL from this study. The strengths of the report are as follows. The study by Abdulghani and colleagues in 2012 serves as a basis for an avian hazard threshold. The LOAL is based on a single-dose egg injection study with imprinting behavior as a measured responsive endpoint. This behavioral measure was very definitive in the study, resulting in a high level of confidence in this outcome. It's important to consider behavioral effects of DEHP that may have severe effects in wild birds, especially at very sensitive stages in their development, as part of a suite of measures to establish an accurate LOAL. However, the draft report also describes a study from Wood and Bittman in 1979, who reported a decrease in egg production and increase in cholesterol in hens fed a diet with 1% DEHP. The reason for not using data from that study was that the study reported group mean body weight changes for each week in a table. In that the food consumption was only reported graphically. It's true that this is a clear limitation, but food consumption could be estimated with reasonably low error from the plot, meaning the figure. The values are shown in grams per hen day, ranging from 8 to 120, with tick marks on 5 grams. It would be reasonable to estimate the food consumption to the nearest 2.5 gram per hen day from the chart to make use of the results from this study and provide more evidence for the proposed LOAL. An added benefit would be a route of exposure, meaning oral rather than egg injection, which is more realistic for an exposure scenario in wild birds. Weaknesses. The draft environmental hazard assessment for DEHP only considered a specific behavioral endpoint, meaning lack of imprinting behavior, of the study by Abdulghani and colleagues for estimating hazard threshold. Behavioral effects from toxins can be excellent biomarkers of effect, but as detailed below, may be less sensitive than that of physiological measures. Further, this study contained numerous physiological, histological, and biochemical measures that are also relevant, and in fact indicative of a LOAL that should be much lower, about 10 milligrams per kilogram or lower. Therefore, there was a failure to consider and describe a broader literature, including more recent studies, to provide context to the key study of Abdulghani, dismissal of most sensitive endpoints in the selected key study, failure to identify the severity of more sensitive endpoints by adjusting the hazard value. As pointed out in charge question 2, studies in wild birds documented DEHP that varied with the studies and the locations in which the bird eggs were sampled. ECB 2008 risk to birds from eating contaminated mussels showed that in that study and others provided indicative information of adverse effects from phthalates, in addition to DEHP, that related to exposure and measured egg contents. However, these field samples contain much lower concentrations than in the Abdel-Ghani study. Based on this and other laboratory studies, the low L should be lowered to 20 milligrams per kilogram concentrations in eggs. In vivo studies using higher concentrations of DEHP, which were 250 to 1,000 milligrams per kilogram, showed definitive adverse effects on body weight, organ systems, kidney, cardiac, and reproductive systems. There does not appear to be consideration of metabolism in the Abdel-Ghani study. It is known that the chick embryo expresses esterase to metabolize the diester phthalates to monesters, which are a toxicant similar to what's seen in mammals. These are big unknowns that could make the no-L and low-L values inaccurate, meaning either too conservative if metabolic activation is too slow, or perhaps biologically less relevant if the monester predominates in vivo after oral exposure and causes different toxicities. It should be noted that the description of the avian assessment is a meager 2 paragraphs in length. This is a clear indication of the inadequate treatment given to this hazard assessment. The reference study shows gross physiological abnormalities, including externally protruding organs at 20 milligrams per kilogram, with a no-L of 5 milligrams per kilogram for that type of endpoint. The article that EPA has cited for this work states gross malformations and severe motor dysfunctions appeared in the phthalate-treated animals, except for the low, meaning 5 milligrams per kilogram dose of DEHP. This included gastroschitis, a disorder resulting in opening or weakening of the abdominal muscles, allowing internal organs to protrude externally. BMD can be used with these data to determine effect data. The no-L of 5 milligrams per kilogram is listed in the EPA Ecotox database, and the 100 milligram per kilogram exposure is listed as the maximum concentration showing effects, which happen to be the maximum concentration tested. Therefore, the 100 milligram per kilogram value is not appropriate for use in evaluating avian toxicity. This type of bias in data selection is troubling and must be corrected in this instance and perhaps in other places in this assessment to protect the scientific integrity of the assessment. Perhaps a better number would be a geometric mean of the no-L and low-L, meaning the square root of 20 times 5 milligrams per kilogram, or 10 milligrams per kilogram. Thus, the hazard value for the avian species in Table 4.1 is incorrect and should be lowered to at least 20 milligrams per kilogram as the low-L and 5 milligrams per kilogram as the no-L. Further, entering the Abdel-Ghani data into EPA BMD modeling package yields a BMDL between 8 and 30 milligrams per kilogram. In addition, other studies in wild birds are pertinent for establishing field exposures and field relevant concentrations. There's a list of references provided that should be considered in estimating hazard and risk. Data for shorebirds demonstrate that DEHP can be present in the preening glands, and that's the oils that are produced, of birds at concentrations of 10 nanograms per mil and are routinely found in the 20 to 80 nanogram per mil range. Potential exposures through breakdown of plastics and the ubiquitous presence of microplastics throughout ecosystems will increase the hazard and risk of exposure in wild birds and should be included in this draft report. One must access avian exposure data in the risk determination document to evaluate the remainder of the question. Upon accessing the publication by Hubert al., it's apparent that the sites are remote and have little bearing on phthalate exposures nearer to production or disposal sites for phthalates or phthalate-containing products. There is no information in the docket about ecological exposures. Phthalate monoester acids, esters, or diacids are not measured, and given the susceptibility of phthalates to metabolism, amounts of these transformation products would be indicative of higher exposure than is demonstrated by the parent compound. This is an important consideration given the demonstration that monoethyl hexylphthalate, or MEHP, and DEHP exhibit similar in vitro toxicity to the chick embryo. Moreover, the primary source of energy for a developing oviparous embryo arises from the lipids in the yolk. Lipases are a primary mechanism of dialkyl phthalate conversion to monoalkylate products, and we provide a diagram of that metabolic pathway. Thus, simply quantifying parent phthalate in eggs is not an indication of likely toxicity. There's no way to directly compare residues from field studies from Hubert et al. To residues in the chicks with abnormalities in the Abdul-Ghani study without a DEHP body burden in the chicks from the cited study, or PBPK models for phthalate transformation in birds. Either of these approaches would allow reasonable comparison of the DEHP burdens in eggs to the original dose in the egg. Interestingly, Harris and co-workers determined DEHP conversion rate in chick embryo cell culture. The rate is 0.5 plus or minus 0.3 picomole per milligram protein per minute, and that's a mean and a standard deviation. Perhaps that rate and the normal growth rate of a chick could help estimate how much DEHP could be converted to MEHP in ovo. There are two papers that provide useful information related to phthalate concentrations in avian eggs. The former reports mono and diesters of phthalic acid in shorebird eggs. The latter reports phthalates in free range and other types of chick eggs. Most of these will improve the exposure estimates for wild or free-ranging birds. Interesting, Kazukiran and al. Also estimate human ingestion from free-ranging chicken eggs, which should inform the human health assessment for exposure. One additional paper provides aggregate phthalate exposure to Arctic birds. Unfortunately, the individual phthalate data are not in that paper. The underlying data for those phthalate concentrations, however, can be found in citations in the Bianchini and al. 2022 paper. Specific comments. DEHP is released into air, water, soil, and sediment with sources that include industry breakdown of plastic products and leachates from waste disposal sites. There is literature showing measurable levels of phthalates in bird eggs, with references attached to this draft report. The draft ignores studies that document adverse effects from DEHP exposure, which could reveal potential risks from lower concentrations and accordingly could lower the hazard threshold. There is evidence from laboratory studies for adverse effects from exposure, specifically to metabolic and reproductive endocrine systems, oxidative damage or reactive oxygen species, and toxicological effects due to DEHP and from other phthalates. These effects include direct actions via receptors and other mechanisms, including aromatase enzyme inhibition, etc., that impair gonadal development and function, impact liver enzyme function, alter thyroid function, and overall health. The mechanisms involved in the adverse effects of phthalates, although similar to those observed in mammals, can have different effects due to a higher metabolic rate, body temperature, unique characteristics of the reproductive system, which include internal organs and a single ovary with multiple follicles, and energetic demands of migration. So simply said, there could be a phthalate syndrome characterized for birds as well. The avian embryo is constantly exposed to the damaging effects of maternally deposited phthalates throughout incubation, as the yolk is the primary depot for lipophilic compounds. Although EPA determined DEHP poses a hazard to terrestrial mammals at a dietary dose of 89.79 milligrams per kilogram day, supported by lab rodent models, the threshold is set higher in birds. The EPA cites a two-generation inhalation reproductive system in Sprague-Dawley rats for the outcomes of acute and chronic hazard identification and dose response determination used to determine a POD. The egg injection study by Abdul Ghani and colleagues provides clear outcomes and demonstrates adverse effects across a dose of exposures. And as mentioned above, only the loss of behavioral imprinting outcome was considered acceptable by EPA for hazard threshold. Additional aspects of the study should be considered, and that is shown in the table provided in the article, but include hatching rate drop from 80% to 65% with increased late hatch at 100 milligrams per kilogram. It was already 57% hatch and 37% late hatch. And so that's the high level. But there are developmental effects, 8% at the low dose to 22% at the high dose. These data should be considered when determining adverse effects. Abolishment of imprinting performance was at 100 milligrams per kilogram dose, which is much higher than the low L for other adverse effects from exposure. There's a corn oil carrier, and it's injected 60 microliter per egg into the albumin. So the site of injection is also one that should be considered. Imprinting ceased at 100 milligrams per kilogram, but there was also significant DNA damage. And urea decreased, creatinine decreased, alkaline phosphatase increased at that level. In addition, BMDL analysis of the data from that paper yields a BMDL of 8 to 30 milligrams per kilogram for the top two model equations. Interestingly, the geometric mean of low L and no L is 10 milligrams per kilogram. So the lower end of the BMDL range agrees with the geometric midpoint of those effect levels. So regardless, 100 milligrams per kilogram is incorrect. Developmental effects are likely with exposure in birds due to maternal deposition into the egg yolk, in which DEHP would be highly soluble. Maternal deposition would result in embryonic exposure throughout embryo development and early post-hatch due to consistent utilization of the yolk for nutrition. There is debate about comparison between laboratory studies using egg injection exposure in wild birds. The timing of injection and placement are critical, as are carrier solutions, both the chemical effects and the injection volume. So that needs to be looked at. Considered. The issue of microplastics and their presence throughout the ecosystem raises the issue of increasing exposure to the breakdown products, especially for wild birds and mammals feeding in areas containing landfills, notably gulls and other species. Marine birds are also increasingly at risk from the movement of microplastics and breakdown chemicals into marine systems. Eggs of wild birds contain measurable concentrations of phthalates, possibly associated with ingestion and maternal deposition of microplastic metabolites, and those have been documented. Phthalate metabolism is going to occur both in field-collected, maternally deposited situations, and in eggs in lab studies that with injection at day 0 of incubation. Theoretically, they should be the same or similar, but we don't have those data. Maternally deposited chemicals distribute throughout the egg and constantly expose the embryo. Ellen Ketterson in the Lipar et al. 1999 paper showed maternal deposition into egg layers. We also showed differential movement of egg-injected PCB during embryonic development, and those references are provided. The point is that exposure to the avian embryo is chronic throughout development, and absolute exposure concentration of low L is likely less than that injected. And that's been shown in other studies. Even if we don't have a direct comparison for phthalates in field and lab studies, the low L is lower than either injected or maternally deposited concentrations, as we know from the literature to this point. Finally, pointing out that gavage studies in female rodents have similar challenges, with the embryo, the mammalian embryo exposure being relatively lower than the administered concentrations. This is a great rationale for 10x plus for NOAL or HED. The key study selected for determination of the avian value, hazard value, therefore presents data on multiple measures, and as mentioned above, the behavior is inadequate for computing the hazard value. And otherwise, EPA stated that gross malformations could not be used in the risk assessment because it appeared that the DEHP data may have been combined with DPT data. I've already mentioned some of those comments above, but the question is if EPA misinterpreted the publication on this point. EPA's statement on line 4978, page 226 of the draft DEHP risk evaluation, states that no other effects on apical outcomes were observed in avian taxa, even at high doses, is incorrect and must be edited to reflect not only the apical effects on developmental malformations, but also observed toxicities in other avian studies. The recommendations are as follows. Given the confidence in the data produced by Abdul et al. In 2012 study, other technical studies using an egg injection approach should be utilized to determine the low-al and based on evidence of damage to physiological and endocrine systems across a range of physiological and molecular markers of damage. More recent studies also inform physiological mechanisms for DEHP exposure and provide more precise data for estimating hazard and risk to birds and other wildlife. Additional measurement endpoints should be considered based on the Abdul Ghani et al. Study and from other studies, given the egg injection experiments provide valuable information on the administration of known concentrations and for assessing potential risk and hazard from exposures to wild birds. Reconsider the use of Wood and Bittman's 1980 data with a reasonable estimate of food intake based on the graphically presented data. Consider 10 milligrams DEHP per kilogram or lower as the low-al and 5 milligrams per kilogram as the no-al for increased developmental defect rate in the Ghani et al. 2012 study. EPA should reassess the data in that paper and consider it in the context of other avian toxicity studies. A geometric mean of 5 and 20 milligrams per kilogram may be appropriate for avian hazard value based on this study, but it is also critical to note that developmental malformations of the abdominal organs in this study constitute a severe gross endpoint. If an adverse outcomes pathway were available for this finding, it would nearly certainly be that initiating events would be seen at lower doses for adverse effects. For reasons of the severity of the endpoint, 5 milligrams per kilogram may be more appropriate and an adjustment factor for severity should be utilized. Alternatively, modeling for the dose response trend in the developmental malformations could be done to find a POD, but again, due to severity, some adjustment is appropriate. EPA should consider DEHP and other cross-phthalate effects on physiological systems. Many of these adverse effects are conserved across vertebrate species. Consider additional sources of phthalates, often primarily DEHP, which are emerging with the large influx of plastics into the environment from consumer products, leaching from landfills, and microplastics in models of hazard and risk exposure. And we provide some diagrams that capture these environmental sources and potential effects in birds. Additional comments. Publications relevant to the question of the effects of DHP exposure and physiological mechanisms have been conducted in domestic chicks and Japanese quail. Most of these studies, and we provide references, are in the Japanese quail and have been conducted by a scientific group that have been using relatively high concentrations of DHP from ranging from 250 to 1,000 milligrams per kilogram, administered by oral gavage. A range of physiological responses were documented showing damage to cancer liver, ovary, spleen, GI tract, and mechanisms of action, including altered P450 systems and reactive oxygen species. Decreased body weight and other gross morphological effects were also reported. Studies are available to document detectable DHP in leachates from plastics, from solid waste disposal sites, increasingly the potential for exposure in wildlife. Aquatic birds and marine wildlife may become increasingly at risk as plastics and microplastics become more ubiquitous and break down in the environment. Detectable concentrations of phthalates have been reported in wild birds. And while this is not part of the charge, the risk evaluation document states that EPA has determined that exposure to DEHP is unlikely to result in risk for birds, page 226, lines 4998 to 4999. This determination is based not only on the flawed derivation of the hazard value, but also the comparison to levels in wild bird eggs that may not capture polluted in urban environments. However, the levels found in eggs in studies cited by EPA relate to concentrations of DHP, and that relationship to urban environments is not clear, as I said a moment ago. If the avian hazard value is based on intake via diet rather than egg injection, then compared to a potential environmental uptake, that evaluation would be able to allow for comparison, and this comment was mentioned above as well. The environmental exposure scenarios relevant to avian species did not include exposure pathways that include ingestion from a variety of other sources that were not considered. The risk characterization is limited to COU releases to air and subsequent deposition to soil. The conceptual model on page 30 of the DEHP risk evaluation depicts a pathway from municipal waste landfills to soil to terrestrial species. However, EPA did not attempt to include degradation of disposed items in the environmental exposure assessment. The lack of consideration of plastic waste particles is considerable uncertainty in the overall assessment that may underestimate considerably avian exposure levels. A further exposure pathway for avian species is from aquatic food species such as mussels and other invertebrates to birds, meaning the food web and food chain as well. And it should be pointed out, some of the birds are very high in the food chain. So the question of transfer and even though concentration of these chemicals has been rather discounted, it may be that it would be something to consider. It is difficult to quantify ingestion of food species contaminated with microplastics or sediment that carries DEHP, but that could be an additional source of underestimation and assessment of exposure to birds, such as in dabbling species near aquatic areas, ducks and other species. And that concludes this presentation.
Okay, thank you, Dr. Ottinger. And first of all, apologies to everyone for having to leave. We had a fire drill in our building, and I had to leave. So apologies. Let's hear from our other discussants. Dr. Spade.
Thank you. My comments were captured in the summary.
And Dr. Fanning.
Yes, thank you, Marianne. That captured all my comments. Thanks very much.
Excellent. So the rest of the committee, are there other comments from folks on the committee? This is George Cobb. I actually have one, maybe it's been said enough, but I want to be clear that the Abdul Ghani paper has DEHP exposures alone in the document. Whether they were analyzed alone or not, I can't speak to specifically, but I can say that there's a table with data of DEHP effects alone. And I, with my meager skills, ran a BMD analysis. And so I'm sure that the EPA folks can use those data to come up with some estimate of toxicity for these gross abnormalities. So with that, let's see if EPA has any clarifying questions for us.
Hello. First off, from everybody on the panel, Dr. Otger or others, thank you very much for your time. This is very extensive and very appreciated. I do have a follow-up question as we were working on writing these, and I wanted to just some things that I was thinking of when I heard this, and again, very appreciative of this. I wanted, when we look at the egg injection from Abdul Ghani, and we look at pairing that with the other references that will be forthcoming in the report, and obviously the use of BMD work, I think is going to be that's really good to see that. I'd like for the report or for the panel to comment on the relative statistical power and the sample size from these dose groups with respect to the numbers of incubated to numbers hatched to the number eliciting these defects at the 20, 50, and 100 group in terms of 1 out of 13 incubated or 2 out of 19 incubated, for example, within 20 and 50. I don't want to discount that, but it's part of the consideration and part of what we're thinking. So please, I guess my question would be, please be sure to comment and help us understand your thoughts as a panel on that power for this thing. Also, I was curious as a follow-up, don't need to answer on this, but when we look at this at the landscape and references you'll be providing, I'd be very curious to see if there are other malformations or developmental papers that indicate this so that the Abdul Ghani is more confirmed. And then finally, we would like, or I would like to be able to make sure that we can make connectivity from outward, or what we would call apical survival, growth, reproduction, ecological level population impacts, and make connectivity to reactive oxidative species, molecular work, that endocrine work, as we can make those stronger connections. And so it would be, we would ask to see that in the report, if that's the question. Anyway, I know we are limited, obviously this is great. I don't know if we have time to continue to discuss, but because we've got a lot of other important things, but really appreciate this.
Yeah, if I could make just real quick, for your first point about power, some of the studies, and there's a whole range of studies, have excellent power, especially the ones that are lab studies, and then connecting between the lab studies and the field studies is a key question that we'll do our best to do for you. Some of this might end up with, here's gaps, but here's what it looks like. The other answer to your question is the phthalate syndrome and a lot of the other kinds of mechanisms of action. Based on the Japanese quail studies and some of the other studies that have been conducted, although they look similar to mammals and many of the same mechanisms of action are conserved, there are vulnerabilities that are unique to birds that need to be considered. And we will do our very best to diagram or map out those relationships and answer any questions that you all have regarding that.
Thank you very much, and really appreciate that. Thank you.
I don't know, George, if anyone else wants to chip in to answer those questions.
Do any of the discussants or anyone on the panel have any response to EPA on this?
Nothing specific, just that the committee did note the potential issues with statistical power of the paper. And I think that the point to look for supporting data in other avian toxicity studies and to highlight what context there is in terms of toxic mechanisms will provide that additional support for use of that Abdul Ghani data.
And this is Dan Spade. I'll just briefly say we did in discussion actually, as I'm sure EPA did, actually analyze the raw data from the Abdul Ghani paper. It is, it's a circular argument, I guess, to make a judgment about power because the data result in a significant Fisher exact test, as they are. So it's difficult to make an independent judgment about power because that would be sort of a circular argument. So perhaps the important considerations are that, malformations tend to be low frequency outcomes relative to earlier events in the AOP, and that, we will look for, we will try to address your concern about, identifying areas of consistency with the other references.
And the other comment there is that there's really a suite of measures and measurement endpoints that need to be considered as behaviors pretty far downstream. And so that's why I mentioned that there's something similar to a phthalate syndrome going on, I think, with other species, including birds, and other effects on metabolic systems, including thyroid and potentially immune. But again, many of those have gaps in data, which would be then for future work.
Okay. All right. Thank you. Anyone from the committee? If not, we can move on to our next charge question, and that's charge question 3. And we can hear from our EPA folks about this charge question.
Dr. Cobb, when we were discussing charge question 1, you were out for the fire drill, and I was wondering if you had any comments on charge question 1.
I did. My main comment was that each of the points that we raised about the physical chemical parameters and how they needed to be evaluated and assessed was actually pertinent to all of the phthalate assessments that we commented upon. So that was the primary thing, and the others are not very important. And I think Dr. Lee captured them anyway.
Thank you.
I heard part of that assessment. So yeah, thank you, Dr. Kamal, and we can go to charge question 3 now.
Hello, this is Christopher Green again with the EPA to read charge question 3. Before we read the charge question, I need to note that the final sentence, the word "and vertebrates" was added. So I just wanted to note that for the record. Chronic hazard values for DEHP, as outlined in the draft environmental hazard assessment for DEHP, were identified for aquatic invertebrates and vertebrates. Among the high priority phthalates currently under review, DEHP exhibits the highest chronic potency to aquatic organisms. Significant effects were observed in fish exposed to chronic levels of DEHP, including reduced growth, in terms of length and weight, and decreased reproduction exhibited by specific effects such as reduced gonadal weight, lowered sperm motility, and fewer offspring. A number of authors are noted in parentheses. Similarly, chronic exposure to DEHP in vertebrates affected growth and reproductive endpoints. 4 authors are noted in parentheses. The EPA selected no observed adverse effect concentrations, NOEC, and lowest observed effect concentration, LOEC, values from Chike et al. 2004A and 2004B studies as the most sensitive endpoints. Though similar effect concentrations were noted in other fish species, by using the geometric mean of NOEC and LOEC values and applying an assessment factor of 10, a concentration of concern, COC, for chronic aquatic vertebrates was determined to be 0.0032 micrograms per liter, which is below the limit of detection for DEHP as reported by Liu et al. 2013. Please review and comment on the strengths and uncertainties of the methodology and data used to derive a chronic COC for aquatic invertebrates and vertebrates.
Apologies, but I could not get all of the items off of my screen. Thank you for reading that in, Dr. Green. And now we can go to our lead discussant, who is once again Dr. Ottinger.
Thank you. And thank you to the discussants for excellent contributions. So I'm going to go straight to the scientific rationale. You've already heard the issue identification. EPA did not determine an accurate COC because of a lack of toxicity data at values below DEHP aqueous solubility. EPA did determine a chronic COC based on the NOAL 0.01 micrograms per liter and LOAL 0.1 micrograms per liter for reduced body weight in Medaka fry exposed to DEHP in a 21-day study. The proposed COC is the geometric mean of 0.01 and 0.1 or 0.032 after application of a 10x assessment factor, which gives 0.0032 micrograms per liter. The strengths. DHP and other phthalates occur in aquatic environments, potentially exposing invertebrates and vertebrate organisms. Sources include industrial sites and increasingly leaching of phthalates into the environment from landfills and discarded products containing these compounds. There are clearly documented adverse effects of chronic exposure to phthalates, including toxic and endocrine disruption, especially for DEHP in fish, and that's covered in the draft hazard assessment for DEHP. Data for adverse effects of chronic exposure to DEHP in invertebrates have been documented and reviewed. See ECB 2008, Health Canada 2020. These studies described in the draft environmental hazard assessment for DEHP provide evidence for toxicity and endocrine disruption in fish and aquatic invertebrates. Chike et al. 2004, A and B, Corradetti et al. 2013, Kwok and Lee 2005. There was very strong evidence base comprised of 82 studies with higher medium quality. EPA's assessment that embryo mortality data from Chike et al. In 2004A was not appropriate to set the chronic COC, the magnitude of effects, even when significant, was very small, with a minimum hatch success of 91% compared to 100% in controls. It would be reasonable to look for historical control data to see if typical control hatching rate is less than 100%. But this is a moot point if EPA is not going to use these data to derive a COC. Effects on fry weight gain were roughly dose dependent in the Chike et al. 2004B paper, at least in females, and the magnitude of difference at 0.1 microgram per liter was 15.3% in male and 23.6% in female fry. The selected NOAC and LOAC are corroborated by Zanatelli et al. 2010 in P. reticulata length and weight, Golshan et al. 2015 and C. aureus and 11 for 11 KT and star mRNA. The decrease in 11 KT or their androgen and star in Golshan et al. 2015 provide strong corroboration of mode of action because it's consistent with the known toxic action or AOP in rodents. The phthalate MOA is not as well characterized in fish, but there are some mechanistic studies. Sohn et al. 2016. This strengthens the data given that steroid biosynthesis is largely the same between the two species, and there are data on endocrine disrupting chemicals reducing star expression in teleus fish. This is Mimalt et al. 2005, Bloom et al. 2008, Pruchet et al. 2020. The data utilized for estimating adverse effects on fish are compelling and provide reasonable hazard and risk estimates. Similar, there are data available to show adverse effects from exposure in invertebrates. However, as described above, there are issues about the assay method. EPA's selection of 5 chronic fish studies for consideration, eliminating studies that found hazard values at concentrations above solubility of DEHP is reasonable. EPA's selection of Chiquet et al. Studies for hazard values is reasonable, and confidence in this decision is increased by the fact that in 3 other studies in different species, similar results, meaning the NOACs and the LOACs, were found, table 3-1 of the environmental hazard assessment. The selection of body weight decrements as a key endpoint over the GSI reduction or mortality is supported by a clear dose response trend in the former and lack of dose response in the latter 2 endpoints. Weaknesses. The methods by Liu et al. 2013 are insufficient for determining a concentration of concern for chronic exposure in aquatic invertebrates of 0.0032 milligrams per liter, which would be non-detectable. As such, there are several issues, including the sensitivity of technical methods for detection, which could be resolved by ultra-sensitive methods, and references are provided as well for this. Updated literature should include publications on these more current assays, which should be incorporated into hazard and risk assessments. Evidence supports relatively rapid biodegradation of DEHP in the environment. However, little attention is given to the primary metabolite, MEHP, which has been linked to adverse effects, and this is Park et al. 2020. Estimation of field relevant levels is challenging because of uncertainties in the source of DEHP. Some models have focused on plastic products, manufacturing facilities. However, consumer or commercial inputs and landfill leachate are possible contributors. And that reference is Health Canada 2020. The selected studies did not show perfect monotonic dose response, and because there were only 3 treatment concentrations, this contributed to uncertainty. Using NOAC-LOAC approach from a study that used 1 log dose spacing is somewhat imprecise. It is unclear from the report whether EPA attempted BMD modeling of the data from Chiquet et al. 2004b, which may give a more accurate POD. However, it is also possible that there is no ideal model fit given the non-monotonic dose response. Given the dose response data for the male body weight decrements observed after embryonic exposure in Chiquet et al. 2004a, it'd be preferable to use a probabilistic approach in place of the geometric mean of NOAC and LOAC, or at least include such an approach for comparison and discussion. Liu et al. 2016 present a probabilistic approach and arrive at HC5s and resulting P and EC values for DEHP based on 6 different toxicity endpoints. Specific comments, effects in fish. Laboratory studies were conducted in 4 fish species, used a range of doses in a chronic exposure design, with some experiments beginning in embryo and fry stages and other experiments in young fish. There's some questions about some high doses exceeding the limits of solubility of DEHP, adverse effects such as reduced 11 ketos testosterone or 11 KT, luteinizing hormone LH, were observed. Kwok and Lee, 2005, demonstrated adverse effects in a dose-dependent manner in the harlequin fly. Studies on marine zooplankton also document adverse effects of microplastic exposure. Rensky et al., 2017. Evidence from mammals demonstrated adverse effects of polystyrene breakdown products into microplastics, phthalates and styrene, which may synergize to disrupt ovarian steroidogenesis and follicular atresia. Zhu et al., 2024. Although phthalates vary in their toxicity and endocrine disrupting actions, the pathways adversely affected by phthalates are likely to be conserved across vertebrates. That's from Health Canada 2020, pages 37 to 38. There was a series of papers on DEHP in bottlenose dolphins that may provide evidence of exposure, and this is for marine species, and these data could be brought to bear on whether EPA's environmental release estimates are adequate to capture exposure to aquatic species. And there are a series of papers by Hart et al. Additional references are provided in the list in our response. Species sensitivity distributions. Related to the relative detection limit and the chronic hazard value, the inability of a study over 10 years ago to quantify 3 nanograms per liter is immaterial to the risk question that EPA needs to answer. Please note that nearly 50 years ago, highly respected research reported DEHP detection limits of 0.2 nanograms per liter and average DEHP concentrations of 4.9 nanograms per liter. Jiam et al., 1978. A Scopus literature search was done from 2021 to 2025 using CAS number along with terms quantif or quantit. That search returned 280 references, which contain specific analytical methods and many reports of DEHP in natural, drinking, and toxicity testing waters. These results also inform responses to charge question 2. Wang et al., 2023, determined an aqueous quantification limit, not detection limit, of 6 nanograms per liter using GCMS technique. Similar, Gao reported LODs of 10 nanograms per liter using simple extraction methods. Slight modification of this technique could allow quantification of concentration that EPA stated were not measurable. For example, doubling the volume of extracted water or the injection volume for GC analysis could accomplish this. It is possible that an on-column injection would also increase the sensitivity sufficiently. A 2023 paper by Q et al. Reports an MDL of around 50 nanograms per liter for DEHP using an extraction of a single liter of water and final extraction volume of 1 ml. Simply increasing the water volume to 10 liter and evaporating the final extract to 0.5 ml would produce the MDL that's needed. Work from 2025 demonstrates a detection limit of 10 micrograms per liter for 0.5 liter samples and 1 ml extract final volumes. Again, Gao et al., 2025. Simple extraction of a larger volume or concentrating a lower volume would easily achieve the needed detection limits for aqueous concentration. Notably, no ultra-high resolution mass spec analysis in the EPA reference literature for phthalates in the environment. There is no analysis provided. This is a notable omission that EPA can and should fill through EPA ORD work or through data requirements of those petitioning to have this assessment completed at this time. This comment about data needs and how to obtain them extends to all reviews wherein EPA has received a petition to move a chemical class or class of chemicals up in the list of planned reviews. Also, please note that an MDL is a regulatory construct that is normally much higher than detection limits or limits of detection, both of which most often based on multiple of signal to noise, or 5 to n equals 6 or possibly 8. Most analytical groups now use the terms reporting quantification limit rather than detection limit to describe the threshold ascribed to an MDL by EPA and other regulatory bodies. Studies by Shike et al., the 2004 A and B studies, and Heindler, 2017, use nominal concentrations and may have exposed test organisms to far less DEHP than reported due to sorption of DEHP onto glass test chamber surfaces. Effects in the Shike et al. Studies are convincing, and the effects are steep, even if the concentrations are not rigorously described. If EPA prefers to use single study from Shike, then a BMDL approach may be more appropriate for identifying the lowest concentration at which adverse effects are anticipated. Hong et al. Use species sensitivity distributions to determine HC5s for aquatic species exposed to multiple phthalates. The HC5 for HEDP was 1.05 microgram per liter. The paper from Hong et al. Did not include data from Shike et al. Papers. These data are not in the Ecotox database. This absence of data identifies a deficiency in the compilation of toxicity data in the Ecotox database that has traditionally been maintained by the EPA. This database comment goes specifically to the ability of EPA risk assessments to rapidly and effectively gather data that are needed for exposure, hazard, and risk evaluations. Lack of proper curation of such databases also diminish the public's ability to readily and transparently access available toxicity data being used in regulatory decisions. Data from Hong et al. Included mortality as an endpoint. This data set was reevaluated by removing mortality data, converting all LOX and MATC values to NOx, and adding the Shike chronic toxicity value of 0.032 microgram per liter based on decreased body weight with no assessment factor. The resulting species sensitivity distribution was placed into an EPA SSD toolbox and modeled without body allometric scaling. That process produced the best fit to the data with a logistic function and an HC5 of 159 nanograms per liter. See figure COB 1, and that figure is provided. The predicted fifth centile hazard concentration shown in that figure value for the single regression is 0.159 microgram per liter, or 159 nanograms per liter. The SSD software also generated a list of fits to 6 functions. The logistic function did not have the lowest HC5 among these model fits. The Wheelbill model produced a highly significant prediction of 0.003 nanogram per liter exceedingly. The predicted HC5 using all model fits, meaning a weighted base on each model's goodness of fit, was 216 plus or minus 186 nanograms per liter. That's the mean and the standard error, which provides a lower bound of the mean at 30 nanograms per liter. The HC5 determined using the Weibull regression represented on 1 part in a billion of the weighting in the determination of the HC5. Given the rather large variance in the HC5 distribution, using a lower bound of the mean 30 nanograms per liter is advised. This HC5 of 30 nanograms per liter is well within the experimental error of the measured value of 32 nanograms per liter by Shike et al. 2024. And table 1 COB with the quartile table of HCS predictions for DEHP in aquatic systems is included. This HC5 approach could be refined with additional information from the second SACC study, which would probably produce a lower HC5, and allometric scaling could also refine the assessment. Also, combining the HC5 approach with the estimate using the most sensitive species, an assessment factor provides more than one line of evidence that maximum acceptable threshold concentration of HDEP would be somewhere in the range of 3.2 and 32 nanograms per liter, with 3.2 being highly conservative and 32 nanogram per liter being a more easily defensible MATC. The SACC has repeatedly advised EPA that the SSD approach is essential to achieve scientifically robust risk evaluations. Conducting the SSD analysis with NOACs provides more certainty of species protection and removes the need for an assessment factor. All phthalate hazard assessments in the docket for this review and all future TSCA reviews of chemical use must use the SSD approach. If data are available for EPA, are unavailable, EPA must obtain them through EPA ORD, interagency data sharing, or data requirements from industry that are producing the chemicals under review. Lines 303 to 309, the treatise here is inadequate and must be, at a minimum, provide a summary of the toxicity data as in the sections above. Lines 507 to 509, EPA states with no basis that there is a robust confidence that DEHP produces low risk to aquatic species. The document EPA goes to a great deal of effort to discard data do not conform to this conclusion. There is evidence of toxicity at concentrations below which EPA data have not attempted to measure. That does not mean there is not risk, just risks of bacteria and viruses to human and ecological data existed before humans could measure the presence of bacteria and viruses. Recommendations. Recent publications with newer technology for assay of DEHP and other phthalates should be referenced, and note that sensitive assays can be used to detect these compounds. Consider BMD modeling of SACC et al. 2004 data to determine POD. Utilize data improved methods to determine the COC. The proposed COC is below the LOQ for DEHP, and if this is significant concern for setting the COC, then a recalculation should be conducted. EPA should consider alternative computational approaches to deriving the COC for chronic aquatic vertebrate hazard threshold. The comment and further analysis presented above relative to obtaining data that are sufficient to produce accurate assessment and SSDs should pertain to every data quality and hazard assessment document in this docket. And each such document should be checked to ensure that the documents are not biased towards low or no risk when in fact higher risks are predicted than are being portrayed in the documents. Additional comments. DEHP also has adverse physiological effects in other species, including plants, and a dandelion paper is referenced, suggesting cross-phyla conserved mechanisms from phthalate exposures that could affect all levels of the food web. It is also noted that the risk characterization of aquatic species is not supported due to inadequate exposure data. EPA has failed to include environmental sources of DEHP and other phthalates. And that's it for our comments.
Okay. Thank you, Dr. Ottinger. Now let's hear from our associate discussants, Dr. Spade.
Thank you, Dr. Ottinger. My comments were captured in the summary.
Excellent. Thank you. Dr. Fanning.
Likewise, my comments and many more were captured in that summary. I think there were a lot of points made. I think at the minimum, we wanted to see reevaluation of the data that EPA did focus on to create a better quantitative assessment. But I think the points that were made about data and studies that were missing from the evaluation is very important.
Thank you. Now let's go to the rest of the committee. Are there further comments from the committee? Well, seeing none, let's go to EPA and see if there are comments from clarifying questions from EPA about our comment.
Thank you, Dr. Cobb. This is Mark Meyer from EPA. I believe we don't have any clarifying questions.
Okay, well, thank you very much. And again, thank you, Dr. Ottinger, and all the discussants for pulling that together. Now we can move to charge question 4. If EPA will read that into the record.
Thank you, Dr. Cobb. This is Mark Meyer from EPA, reading charge question 4. In the draft environmental hazard assessment for DBP, section 2.1.1, BBP, section 3, and DIBP, section 3, transcriptomic points of departure, or TPODs, for aquatic vertebrates derived from studies conducted by EPA's Office of Research and Development were included in the weight of scientific evidence with concentrations of concern, COCs, derived from in vivo apical studies for acute exposures in aquatic vertebrates and/or species sensitivity distributions. Please comment on the current application of the TPOD and metabolomic points of departure, MPODs, in the phthalate draft environmental hazard assessments in a weight of evidence manner, and if there are any suggestions for improving their comparisons to the corresponding environmental hazard thresholds, acute and chronic, for future application in TSCA chemical risk evaluations. In your response, please include whether TPOD and/or MPOD data presented in DBP, BBP, and DIBP is sufficient to support a chemical-specific COC.
All right, thank you very much. And our lead discussant for this portion is Dr. Spade.
Thank you. Yes, so I'll read the, can you hear me?
We can.
Yes, okay. So I'll read the summary of the discussant's response. In the relevant draft environmental hazard assessments, EPA derived toxicogenomic, metabolomic, and behavioral points of departure for DBP, BBP, and DIBP. These values were derived from an EPA study that used fathead minnow and was designed and conducted specifically to support this purpose. And that's the Benchich et al. 2024 study. Based on the Benchich et al. Study, EPA derived these values as follows. TPOD was defined as the lowest median benchmark dose limit for a gene ontology category. MPOD, metabolomic POD, was defined as the BMD for the 10th percentile metabolite, and behavioral POD or BPOD was defined as the BMD 50 for reduction in startle response. The agency has proposed to use the DBP, TPOD, and MPOD, but not the BPOD, and not the BBP or DIBP, TPOD, MPOD, or BPOD to in support of the derivation of chemical-specific concentrations of concern. EPA requested that the SACC make recommendations about whether the TPOD and/or MPOD data are of sufficient quality to derive chemical-specific COCs. The committee agreed that the weight of scientific evidence analysis was supportive of the concentrations of concern derived for DBP, BBP, and DIBP, and that the use of transcriptomic points of departure and metabolomic points of departure in the weight of evidence analysis is justified. None of the aquatic toxicology thresholds for these 3 phthalates was based on omics data. Overall, EPA's approach was appropriate, although EPA may have underweighted the omics studies as part of the evidence base. The Benchich et al. Study is high quality and provides strong support to the acute COCs that were derived from the NOAC, LOAC, or species sensitivity distribution analyses. There were several specific strengths of the agency's analysis. First, TPOD and MPOD data was used as part of a strong evidence base for DBP, with 17 studies of higher medium quality for acute toxicity in aquatic vertebrates, including 13 with definitive hazard values below the limit of water solubility. The weight of evidence analysis for DBP in table 2-1 shows strong concordance between TPOD at 0.12 mg per liter and MPOD at 0.11 mg per liter values for DBP, and a logical progression of effect levels from transcriptomic and metabolomic effects at the lowest concentrations, followed by behavioral effects and mortality at higher concentrations. Additionally, confidence in the current analysis is strengthened by higher acute than chronic PODs for aquatic vertebrates, which is consistent with long-term exposure exerting greater toxicity, particularly for phthalates, which have short biological half-lives. Based on these relative effect doses, a POD entirely based on acute mortality is unlikely to be sufficiently protective. Although there is more extensive evidence base for DBP, the source of TPOD, MPOD, and BPOD data for these three compounds is the same in all cases, the Benchich 2024 study. And the committee sees no reason to assume a difference in the strength of TPOD, BPOD, or MPOD data derived from that paper for each of these three chemicals. Inclusion of the data in all three analyses would reduce rather than increase the uncertainty in the risk assessment. Additionally, inclusion of the TPODs for all chemicals would be beneficial to harmonize the endpoints measured across the phthalates. Further, because TPOD analysis incorporates information about overrepresented gene categories, the inclusion of TPODs for all three phthalates can strengthen the analysis by highlighting conserved mechanisms of action of these compounds on the physiology of aquatic vertebrates, which also improves hazard characterization. With respect to EPA's request for advice on incorporation of TPODs and MPODs in future hazard assessments, each of the three environmental hazard assessment documents reviewed by the committee appropriately gave brief context on TSCA section 4H1B that requires EPA to reduce and replace use of vertebrate animals, and then introduces the Benchich study on omics PODs in this context. These alternative assessment methods are justified as a strategy to reduce animal use while providing high quality scientific evidence per TSCA requirements. The committee was in strong agreement that EPA using these modern approaches to testing and assessment will strengthen EPA's determination of risk in this and future assessments. The committee agreed that Benchich et al. Study was strong and that EPA was potentially too cautious in incorporating the data into their assessments because the TPODs presented in the draft environmental hazard assessments would be sufficient to support chemical-specific COCs for all three phthalates. EPA's rationale for not making greater use of the omics-based PODs was that there's inadequate knowledge at this time about how the sublethal effects in the Benchich et al. Study and other short-term exposure studies relate to ecologically important effects. While it is accurate to say that studies with direct comparisons between omics and traditional endpoints may still be limited, there are instructive examples. In the present case, the TPODs and MPODs reported by Benchich et al. Were concordant with the apical PODs. This is consistent with ample support in the broader literature to show concordance between TPODs and apical endpoint PODs derived from short-term in vivo studies in general, which is supported by references from EPA, OECD, and HESI that we will provide. For mammalian reproductive and developmental toxicity of dipentyl phthalate and dicyclohexyl phthalate, and for concordance between apical developmental toxicity effects and transcriptomic dose response. And although the studies cited here are primarily rodent studies, they provide conceptual scientific support for concordance between TPODs and apical PODs. Moreover, EPA could consider existing in vivo and in vitro rodent phthalate data for development of TPODs for terrestrial vertebrate and human health risk assessments. The committee will submit the above references to EPA to consider as support for the future use of TPODs and MPODs in environmental hazard assessment. It is also important to note that the use of transcriptomic PODs is moving forward in human health risk assessment and should likewise move forward in environmental risk assessment. There were potential uncertainties identified by the committee in the agency's assessment, beginning with the weight of evidence analysis for benzyl butyl phthalate. For BBP, EPA reviewed 47 studies of higher medium quality, including 6 with definitive hazard values. The TPOD, MPOD, and apical hazard values for mortality from the benchage study were not included in the weight of evidence analysis. However, there was strong concordance between the TPOD and MPOD values and the apical NOAC and LOAC of 1 and 1.7 mg per liter, respectively, which are presented in tables 2A, 3A, and 6 of the benchage paper. The ratio of NOAC to TPOD in this case was 16.7, which is a higher ratio than for DBP or DIBP. However, these values are internally consistent and concordant with the values considered in table 3-1 of the BBP hazard assessment, which range from 0.51 to 3 milligram per liter for a 96-hour mortality LC50 in 5 different aquatic vertebrates. There was only one hazard value in the literature reviewed for DIBP, so EPA relied on read across from DBP. The TPOD and MPOD from Benchich et al. Should be considered in the weight of evidence analysis for DIBP. NOAC and LOAC for mortality in the Benchich study were 3.6 and 6.4 milligram per liter, respectively, and the LC50 was 5.3 milligram per liter. The ratio of NOAC to TPOD for DIBP was approximately 4.1. The TPOD is based on a biologically relevant transcriptomic pathway related to fitness, namely glutathione metabolism, and there is not a biological justification to exclude these data. Additional uncertainties identified by the committee relate to the nature of the TPOD and BPOD analyses and were considered minor by the committee. These include the availability of only one TPOD, MPOD, or BPOD study in fathead minnow. However, it is an excellent study in design, transparency of methods, and thoroughness of reporting, which minimizes this concern. A second concern relates to the approach to setting points of departure, relates to the fact that the approach for setting points of departure differs for the 3 data types. TPOD was defined as BMDL for the lowest affected gene ontology, MPOD for the 10th percentile metabolite BMD, and BPOD was defined as the BMD 50 from a behavioral assay. These approaches could be standardized or more clearly justified to strengthen the approach. Finally, specific recommendations from the committee, we have 3. So first, the TPOD and MPOD data were sufficient to support chemical-specific concentrations of concern for DBP, BBP, and DIBP. EPA should reconsider inclusion of the TPOD data in their weight of evidence analysis for BBP and DIBP in addition to DBP. Additionally, EPA should assess the availability of rodent in vivo and in vitro omics data and consider whether they would support development of TPODs for terrestrial wildlife and human health. Second, EPA should clarify their reasons for choosing different strategies to derive TPOD, MPOD, and BPOD. EPA should establish a systematized approach for derivation of TPOD and MPOD values and should plan to include at least TPOD values for future environmental hazard assessments. And finally, EPA should take steps to make the Benchich et al. 2024 report publicly available, preferably as a peer-reviewed publication. So that is our summary. That's all I have.
Excellent. Thank you, Dr. Spade. Now to our associate discussants, Dr. Ottinger.
You did a wonderful job capturing any and all things that we brought up. One thing that I would like to emphasize is that the diversity of species that need to be considered, especially once one uses molecular mechanisms, should include a range, and in the last discussion, we talked about dolphins. There are also seabirds and other species that need to be considered in some of these determinations. Thank you.
Dr. Fanning?
Yes, thank you. That was a great job putting together our various thoughts. Thank you, Dr. Spade. I just wanted to add the comment, which was already reflected about the way that integration of transcriptomics into human health assessment has been moving forward considerably over the last years. And with EPA's transcriptomic assessment product, that is currently focused on human health, and we really see an opportunity to begin integrating methodologies for ecological transcriptomic products as well.
All right, thank you very much. Now for the rest of the committee, are there other comments from committee members? And what about clarifying questions from EPA?
This is Anthony Luz with EPA. First, I'd just like to thank the committee for that thorough discussion of the charge question. There's no questions or need for additional clarification at this time. Thank you.
Thank you very much. And I'd like to commend EPA for taking this approach. This is moving the science forward as EPA is trying to streamline these procedures, and it's using the best available science. So I want to give a congratulations for moving down this path and charting a new course. We're kind of in a gray area. We can move to another charge question, or we can take lunch. Maybe I should ask Dr. David if he is ready for charge question 5A1.
I am ready, but lunch is always something that's appreciated.
Yeah, I think it's a good stopping point here because that would be a different subject. So
Yes, since there are a number of parts to charge question 5, it might be better to have an early lunch.
It is a good natural break point, and so we will certainly do that. And then just for everybody's understanding, Dr. Gentry is going to be leading us through the first several parts of charge question 5. So she'll be moderating in the afternoon, the early part of the afternoon today. So with that, I think we're off for lunch for an hour, and I hope somebody can set us a timer up. Thank you, Dr. David and Dr. Kamel, for contributing to our decision-making process.
Okay. Welcome back, everyone. Hope everyone had a good lunch. I guess, is Dr. Kamal here?
He is.
Oh, okay.
He is turning on his volume now.
Okay.
Okay.
All right. Well, before we kick things off this afternoon, let's do a brief roll call and make sure everyone's here. Dr. Chasen.
I'm here. Thank you.
All right. Dr. Cobb.
Here.
Dr. Ike.
I'm here.
Dr. Fong.
Yes, I'm here. Thank you.
Okay. Dr. Fox.
Here.
Okay. Dr. Graham.
I'm here.
All right. Dr. Heiger Bernays.
Here.
Ms. Jenkins.
I'm here. Thank you.
Dr. Lee. Okay, I see you there. Can you unmute so we can make sure we can hear you, just in case?
I'm here. Sorry for
All right.
some technical problem.
That's fine. Dr. Merced Neves.
I'm here.
All right. Dr. Ottinger.
Hello, I'm here.
Dr. Samuel. I don't see her. We'll go through the rest of the list and I'll circle back. Let's see. Dr. Babbage.
I'm here.
Okay. Dr. Ching.
Right here.
Okay. Dr. David.
Yes, I'm here.
All right. Dr. Fanning.
Here.
Dr. Martinez.
Hi, I'm here.
Okay. Dr. Rollins.
I'm here.
Okay. Dr. Spade.
I'm here.
Okay. And Dr. Wolf.
Present.
Okay. And Dr. Sommel join us.
I think she said she was going to be out for a minute right around lunchtime today. I think, or maybe that was yesterday. I've lost track.
Okay.
Yeah, I think today.
Okay. But we're good with quorum. Dr. Kamal?
Yes.
We're good. We're good.
Okay. All right. Well, I guess we'll get started with the first of many parts of charge question 5. EPA, if you'll introduce the charge question and the first part.
Good afternoon. I'm John Allran with the EPA. Charge question 5. EPA has developed draft non-cancer human health hazard assessments for DCHP, BBP, DBP, DIBP, and DEHP, as well as the draft meta-analysis and benchmark dose modeling of fetal testicular testosterone for DEHP, DBP, BBP, DIBP, and DCHP, which supports the dose response assessment presented in the non-cancer human health hazard assessment for each phthalate. Next slide. Before I get to charge question 5A, 5A1, I wanted to note that after the previous SACC meeting, we have deleted the reference to metabolic syndrome and added a reference to lipid metabolism, as the diagnostic criteria for that was deemed to be too narrow to support the charge for the question we're trying to ask. So charge question 5A. In the draft non-cancer human health hazard assessment for DEHP, EPA discusses the weight of scientific evidence for effects of DEHP on nutritional/metabolic effects related to glucose/insulin homeostasis and lipid metabolism in sections 3.2 and 3.9.
and effects on the female reproductive tract in sections 3123, section 3132, and section 39. Although these hazards may inform potentially sensitive PODs, EPA identified substantial deficiencies and limitations in the evidence, including lack of replication and inconsistencies regarding the dose response, temporality, directionality, and magnitude of changes in parameters examined, which reduces EPA's confidence in using these hazards for quantitative dose response assessment. Therefore, EPA has preliminarily concluded that there's too much uncertainty associated with these hazards to support quantitative dose response assessment and POD determination. So charge question 5A1, please comment on the strengths and uncertainties pertaining to EPA's preliminary conclusions on the nutritional/metabolic effects related to glucose/insulin homeostasis and lipid metabolism.
Okay, thank you.
Nothing there. Okay.
I'll turn this over to Dr. David, who is our lead discussant for this part of charge question A.
Thank you, and thanks to my colleagues for their input. The quick response to the question is we agree with the agency's conclusion that the current evidence is insufficiently clear and consistent to support or conduct a quantitative dose response assessment and to develop a POD. So metabolic syndrome is diagnosed based on the patient having several features, including insulin resistance, abdominal obesity, dyslipidemia, hypertension, which can occur in various combinations associated with a variety of risk factors, most of which are typically not associated with chemical exposure. On the other hand, there are some epidemiology studies that suggest an association between exposure and endpoints of metabolic syndrome in humans, and we comment on that a little bit later. So the point is that the metabolic syndrome remains a concern, and the agency has identified some endpoints within the animal database that have some consistent findings, at least in younger animals. So the strengths of the decision, first of all, the EPA's conclusion is consistent with other regulatory bodies. I mean, a comparison of the POD for this endpoint with those for the reproductive endpoints should be justification for the exclusion of the nutritional metabolic effects. Treatment of laboratory animals with DEHP, as with other PPAR alpha activators, has consistently resulted in reduced body weight, normal glucose levels, apparently reduction in body fat, and seemingly the opposite of what might be expected in the metabolic syndrome. And that actually is for adult animals. For younger animals, there does appear to be an impact on some of these endpoints. And I might add that in the review of animal data, you may want to add a chronic study by David et al. At 2000 that measured some of these endpoints in animals that were exposed to DEHP for their lifetime. With respect to humans and the association of exposure and body fat, you have to remember that substances such as DEHP can be sequestered in body fat because it's a very lipophilic substance, and studies have shown that's associated with fatty biological fluids such as mother's milk. Also, the association of obesity and DEHP exposure may be associated not so much with the DEHP causing the effect, but again associated with body fat because humans may consume more food that is in contact either with food packaging or we already know from NHANES surveys that food is a source of exposure to phthalates. So one has to be careful about the spurious associations with respect to body fat and people who may be overeating. The uncertainties, certainly most rodent animal models are not good predictors of obesity unless the species are genetically modified. So there are animal models for diabetes, especially those that have tested potential therapies for treatment of diabetes, and they use blood glucose levels as the most common endpoint of measurement. And that could be used to help characterize diabetes risk. The action of DEHP on PPAR alpha and the experimental data do not really support metabolic syndrome. And unfortunately, the mode of action, underlying mode of action for metabolic syndrome is not well understood. So its relationship to DEHP exposure is not entirely clear. There are too many uncertainties regarding phthalates and their association with metabolic syndrome to discuss any real relationship between the two. But robust epidemiologic evidence is not a requirement for a POD or endpoint selection from animal studies. And fully developed adverse outcome pathway is not a prerequisite for a POD or endpoint selection. And that is something that the agency will need to consider as moving forward. So with that short summary, I'm happy to ask my fellow colleagues if they have anything to add.
Dr. Wolf?
Here we go. Yeah, so I appreciate the agency in their revising the charge question to remove the metabolic syndrome, and there's a lot of more text that won't need to be added to the final document if they pursue that and not and just eliminate the discussion of metabolic syndrome in the document because it is a complex, not disease, a collection of features in a human patient that are lumped together with this syndrome designation. And so I think it just is confusing and really isn't necessary to establish the health protection goals.
Okay, let me get to the other associate discussants. I see several hands up, but I'll make sure we get around to everyone. Dr. Merced Nieves, you have anything to add?
So thank you, Dr. David, for that nice summary. I know we had quite a few comments. I would like to add something about food packaging. I think there is an assumption that food packaging might be fatty foods, but I want to remind everyone that vegetables come in both cans and frozen in plastic bags. So we also have exposures in healthy foods. So that while I agree that currently the literature leaves for uncertainty, and like I agree with that first comment that Dr. David mentioned, I would not completely dismiss the EPI studies, specifically the NHANES one, because again, we have susceptible populations that have higher consumption of canned foods and frozen foods due to different socioeconomic status. So I just wanted to add that.
Okay, thank you. Dr. Fox?
Nothing to add.
Okay, thank you. And Dr. Heiger Bernays?
I would also like to concur with Dr. Merced Nieves's point. And thank you, Dr. David, for presenting as you did. I am a little confused at this point with the slight change in definition or that the agency is using. And I just want to make sure that the language that is, I just want clarity on the language of the charge question. Is it as written or has it been revised again?
Yes, thank you for the asking for the clarification. So our intent in asking that question was to provide a broad enough charge to the SACC to be able to respond to the suite of evidence that encompasses all the studies in animals on glucose homeostasis and insulin homeostasis and all the numerous parameters that support that with lipid metabolism. And so I think we latched on to the term metabolic syndrome to try to encapsulate that suite of effects. But in the previous meeting with Dr. Wolf, he indicated that term implied specific diagnostic criteria for humans that we felt limited the charge too much. So what we're really asking is to look at the animal evidence in concert with the epidemiology evidence and all those parameters that are involved in the studies in that section and determine if there's enough strength in the evidence that's robust for spear-sided POD, or if you agree with the way that we've addressed it.
Okay, thank you very much. That's really helpful. I would like to reiterate, though, that the epidemiologic evidence do suggest an association between exposure and endpoints of both the metabolic syndrome and sort of that revised criterion. And I don't want to lose that. So how those data get incorporated, whether that's in a quantitative approach to the POD, I think as stated in the response, that the approach that was used is supported, but I want to make sure we don't lose the epidemiologic evidence for those endpoints. And a point that I'd actually raised in my comments that were not in contrast to what was stated, but the body of evidence along the lines of lipid, I'll call it lipid homeostasis, glucose homeostasis, metabolic syndrome, have really evolved in the past 10 years, right? And the studies to be able to measure specifically dyslipidemias in a robust and repeatable manner in animal studies, those have not been considered in this body of evidence. And so while I support the conclusion, I want to make sure that, because I understand the agency's under a time crunch, but those additional studies they're not exactly in line with the EPI studies, but they are supportive mechanistically. And again, I shouldn't say mechanistically, I should say observationally. And we don't need a mechanism of action to be able to identify the point of departure. And as stated, concurred, PPAR alpha, for example, is not that mechanism. So where am I going? That is the question. Okay, I support what was stated. I don't want to lose this thread, which is incredibly important, which is these lipid glucose endpoints that for which the evidence is accumulating in the epi world and in the animal models, using the right animal model, right, to answer the questions. And I will provide citations, Schlesinger et al. And a bunch of others, that this metabolic, I'll use that term now, metabolic endpoint and its relationship, clear relationship with these phthalates, DEHP in particular, that evidence is accumulating and should at least be recognized. So thank you.
Okay.
Thank you.
Thank you. Dr. Ottinger.
That was a terrific summary, and I just wanted to add a couple of friendly suggestions, which is pest populations and also comparative biology of aging bring into the fore the fact that there are vulnerabilities not only over the lifespan, but over where people live. And that second point's been brought up already. But especially with metabolic changes, thyroid function declining with aging, and all sorts of other endpoints that are likely to be altered by exposure to phthalates, that if that could at least be mentioned as another factor that we need more data to fully understand the potential adverse effects, that would be great.
Okay. Thank you. Dr. Rollins?
All right, thank you. Yeah, I just want to reiterate what Dr. Doug Wolf had mentioned. It's the difference between a syndrome versus a diagnosis. And syndrome is simply a collection of signs and symptoms. They tend to occur together, whereas a diagnosis is the identification of a specific disease or condition based on those signs and symptoms. And so a syndrome is not elevated to a disease unless it passes more restrictive, probably, thresholds to become a disease. And so what we're talking about here is a syndrome, not a disease. And I think we need to be clear about that distinction. That's all I want to say.
Okay, thank you. Dr. Cobb.
Very quick comment related to Dr. Mercednieva's comment. And this stems back to the cumulative risk assessment phthalate documents that we reviewed as a committee a few years ago, and to some of Dr. Chasen's comments yesterday about whether or not those recommendations were taken into account. Having excluded food consumption leaves a gaping hole in the risk assessment, especially when you consider microwavable plastics in which food is cooked, and those high temperatures will release phthalates into the food. So that's a gaping hole in this assessment that needs to be at least pointed out, in my estimation, whether it's a majority opinion or not. Thank you.
Okay. Is there anyone else from the committee? Dr. David?
Just as a reply to Dr. Cobb, there is a common perception that phthalates are used in containers that are microwavable, and I have to add some caution to that, because I'm not sure that that is entirely correct, and it would be up to the agency to confirm. I know that adipates, for example, are used in cling film, but phthalates as such, I'm not sure that those are used in those kind of microwavable products. So that's something that would need to be determined.
Okay. I understand what you're saying, but I think EPA is simply not addressing the question, which is a problem. But thank you I appreciate the dialogue.
Okay. Dr. Rowland, your hand is still up. Do you need to make another comment?
No, sorry about that.
That's all right.
There you go.
Anybody else from the committee? Okay, EPA, do you have any clarifying questions?
No clarifying questions from EPA.
Okay. I guess we will now move into charge question. I hear echo. Charge question 5A2.
Okay. Let's cut it off. Screws down. Okay. Okay, so charge question 5A2. Please comment on the strengths and uncertainties pertaining to EPA's preliminary conclusions on the potential hazard DEHP poses to the female reproductive tract.
Okay, thank you. And I will turn it over to Dr. Martinez as our lead discussant.
Hi, can you hear me okay?
You're a little grainy. I don't know if that, yeah, gravelly, not very clear. Is anybody else hearing that?
Yes.
Well,
Yes.
maybe
Yeah.
if I speak up, would it help if I speak up, or is it my earphones?
It may be the microphone, isn't it?
Yeah, it sounds like a microphone issue.
Okay, I think I'll have to switch to my other device. Sorry about that. Just trying to be conscientious about everybody. And I apologize for this delay. I'm gonna switch.
Okay.
Hey, do not worry. I had to leave my building. These are the technological issues we have to deal with for virtual meeting.
Let's see. You're on mute now. Looks like, or
How about now? Can you hear me now?
that's better.
Okay, that's better. Sorry about that. Let me just make sure my microphone is going okay. So for the issue identification, in the draft non-cancer human health hazard assessment for DEHP, EPA reviewed evidence of DEHP's effects on the female reproductive system. And due to significant limitations such as lack of replication and inconsistent dose response patterns, EPA found the data too uncertain for quantitative dose response assessment or point of departure determination. These limitations justified excluding these studies focused on very low doses or effects not clearly linked to a defined mode of action for reproductive disruption. While DEHP does impair female reproductive development, the variability in the study results led EPA to base the point of departure on effects of the developing male reproductive system, which is expected to be protective across age groups. So half of the committee agreed that the conclusions drawn by EPA regarding the non-cancer effects on the developing female reproductive tract are reasonable and supported by their assessment of the strength of the data. The rest of the committee disagreed and proposes that despite the weaknesses in the individual studies, the studies converge on a similar mode of action, and it seems that failing to consider them at all may lead to an inappropriate exclusion of this large body of literature. As a comparison, EPA proposed the DHP Lowell for avians based on only one study. So the scientific rationale is that overall, the committee thought the EPA did a thorough review of the studies on the female reproductive toxicity of phthalates and focusing on the biological plausibility effects on the developing ovary. And the strength of this section is that EPA seems to have gathered many studies on both reproductive systems, male and female, in human and animals. For the animal studies, the committee made comments on each study, and I'm going to start with the first one, which is the Zhang et al., where they considered, in this study, animal study, they did only one very low dose of 0.04 milligram per kilogram per day. And the key uncertainties of the study was they had lack of dose response, small sample size, and timing of follicle counts. And some of the effects reported were not clearly related to the overall mode of action for disruption of female reproductive development. And then the other study that we gave support to is looking at the peripubertal female rats treated with DHP exhibited early puberty accompanied by increases in GnRH and modulating signaling pathways. That was a study by Xiao et al., and they included an accelerated accelerated sexual maturation method that differs from other studies in that they used younger rats of 15 days old. So notably, in the difference between like Shao et al. And Grand et al., they had conflicting findings, and one showing accelerated puberty, the other delayed. And this underscores that there's variability in outcomes and the importance of exposure timing during development. The next study they looked at was a POCAR study where they looked at effects on, where they showed that the effect on sperm count and oocyte maturation or degeneration did not lead to defects in the mating performance. However, this endpoint is in rodents is very challenging. And so for this reason, alternate fertility pathways have been developed in rodents, such as utero insemination with a controlled number of spermatozoa. And the body weight changes by POCAR et al. Are significant, and as SDR points out, likely are transient. For the multi-generational effects in POCAR et al., the effects are seen at the lower dose and not at the higher dose. And that this does not necessarily imply that it is not dose related. And furthermore, the slope of the dose response curve, which was first reproduced in their 2017 publication, does not provide sufficient information for an effect, and certainly not for a point of departure. And the EPA is justified in this assessment. And then the next study by Andrade et al. Used a much wider dose response with appropriate dose spacing, but it only focused on the brain aromatase activity, which was variable and within dose, and showed a non-monotonic dose response. However, the two adjacent doses were significant in the low dose range. So related to like these three studies, the last three studies, the Shao et al., POCAR, and Andrade, the committee recommendation is that maybe clarification could be made to include the potential for non-monotonic dose response, specifically looking at the application of the FSA approach that's recommended for applications in cases of apparent non-monotonicity. And more importantly, it's just like to say that these effects are not valid. It's just maybe they are just are non-monotonic, and that should be clarified in the report. And then the next topic is related to the inhalation study outcomes. And so in the decision to discard the inhalation study outcomes due to uncertainties that would exist in most reasonably studied designs does not represent the use of best available science and cannot be supported. The reasons for not accepting the inhalation studies include factors that would counteract one another in terms of increasing or decreasing exposure. So for the case of potential dermal exposure from inhalation, exposure can be modeled, and regardless if the exposure is from atmospheric source. The same is true for potential ingestion from rodent grooming practices. These exposures would be part of an atmospheric route, regardless of the route by which it entered the body. All inhalation exposures have an ingestion component, as the passages to the lung and digestive tracts have areas in common, and the mucosa and saliva will wash deposited vapors and particles into the stomach. This has previously been discussed in EPA SACC meetings related to probabilistic ecological risk assessment. If there were a superior data that could be used for more quantitative exposure and effect estimates, then there could be a case for discounting the current studies. So a recommendation from the committee is to use inhalation studies to develop an appropriate point of departure. And then the mode of action, we're going to talk briefly about the mode of action. It appears that DHP attacks the developing female reproductive tract through actions including increasing oxidative damage and steroid synthetic and functional pathways. The actions of DHP and its metabolites involve increased oxidative damage and interactions with steroid receptors, thereby interfering with steroidogenesis and impaired steroid-dependent pathways. So even at low doses, effects are likely to interfere with ovarian function, recruitment, development, and maturation of ovarian follicles, and potentially altering reproductive lifespan by reducing ovarian reserves. So those were topics on the animal studies, and we'll switch to human effects now. So it appears that DHP human exposure may be the most damaging to reproductive development phases in the life history. However, data in humans were variable in terms of adverse effects on pregnancy and puberty in females. The epidemiological evidence is only utilized as qualitative support as part of the weight of evidence. The EPI studies do not support a quantitative POD, and animal studies should be utilized to confirm the POD. The variability in the EPI studies in females do not support the quantitative POD. I'm sorry, repeating myself. And it applies to females and males across life history, especially with aging. So recommendation from the committee was in the table 3.2 that summarized the Radke study, that they think it's a good tabular representation, but it did not evaluate the studies that demonstrated effects. So there's no reasonable way to use the Radke conclusion as a basis for excluding other studies that demonstrate adverse effects. The committee recommends including a table with each of the studies that demonstrate adverse effects, like the table 3.2. And then most of the correlative studies focused on urinary DHP metabolites, which may be limited to timing of measurement. And specifically, human urinary DHP metabolite should be detectable at the time of an acute exposure, or in cases of chronic exposure would be more salient for understanding potential adverse effects associated with DHP actions over time. Some additional recommendations were that the metabolite of DHP, MEHP in the human body has been linked to adverse effects and should be considered in assessing potential risk from exposure. And then with the biological plausibility beginning on line 2102, the committee recommends that EPA consider that a complete AOP is not required to establish biological plausibility, and that the proposed effects of phthalates on the female reproductive system occur through analogous methods to the male reproductive system, including suppression of steroid hormone biosynthesis and the expression of genes required for steroidogenesis. Although there is less consistency in endpoints and study designs in the female studies than the male studies, there is argument for biological plausibility. We think that the EPA should include the Health Canada data rather than discarding it, as ATSDR pointed out the paucity of studies and the findings of lower fertility, diminished egg production, ovarian antral follicle count, as well as increases in preterm birth is strong evidence that EPA should consider these effects rather than dismissing them. And then the argument for giving further consideration to the female reproductive studies, the recommendations are that EPA should not dismiss the findings of diminished egg production, ovarian antral follicle counts, as well as increases in preterm birth, as these are still impactful results for women's health. Further, although the assumptions that the male point of departure is sufficiently conservative to apply to females, other studies should be conducted to confirm this at reproductive and other life stages, such as menopause. And a table of adverse effects, as well as studies that do not demonstrate adverse effects, should be included for the reproductive studies, and the endpoints that are included to determine if consensus, NOEL, and LOEL emerge. And EPA should proceed to evaluate the hazards and risks of DHP to female and male reproductive tract effects. If there is uncertainty, then assessment or uncertainty factors are available to lower the adverse effects concentration threshold. And then the last recommendation was that EPA should consider the recent meta BMD analysis of data from the Jody Flaws group, which was published by Silva et al. 2025, which will include the reference, which calculated BMDL5s of 9.1 milligram per kilogram per body weight per day for serum progesterone and 19.5 milligram per kilogram per day for altered follicle count. The analysis encompasses 4 studies with a dose range of 0.02 to 250 milligram kilogram per day for studies in adult rats with exposure duration of 10 to 30 days. And those are all the comments we have for this section. And did we miss any?
Thank you, Dr. Martinez. We'll go through the associate discussants and see if there's anything to add. Dr. Ottinger?
Thank you, Dr. Martinez. That was fantastic, and you included everything. I'd like to emphasize one point for folks. I believe Jody Flaw's work deals with adults, but again, I'm going to circle back to the idea of menopause and ovarian reserve and differential effects of these chemicals potentially on females and ending their reproductive lifespan earlier than males, which consistently have renewal of primordial germ cells throughout their lifespan. So there's a big difference in the potential adverse effect for the human and other females in the comparative biology of aging arena that would limit reproductive lifespan.
Okay. Thank you, Dr. Ottinger. Dr. David?
No additional comments.
Okay. Dr. Merced Nieves?
Thank you, Dr. Martinez, for that nice summary. I agree with everything that was included. And also I agree with Dr. Ottinger's comments about the complete life cycle. Thank you.
Okay, thank you. And Dr. Spade?
My comments were captured in the summary. Thank you.
Okay, thank you. Anyone else on the committee have any comments? Okay, if not, we'll ask if EPA has any clarifying questions. Oh, I'm sorry. Hands went up and my system didn't see them. Dr. Cobb.
I think Dr. Babich was first.
Okay.
Thank you. I just looked through the DEHP document and I didn't see any citations of Dr. Flaw's work. And I'm wondering if that shouldn't be at least mentioned in the document. Because there's a lot of, I found 12 pages worth of citations for her.
This is Dan Spade. I'll just briefly say, because I reviewed this, that there were, Jody Flaw's papers cited in the document and discussed, but she has a number of recent papers, including that Bayesian benchmark dose analysis that was mentioned, that I think would be really useful updates to the literature that is reviewed by EPA. So yeah, I agree with Dr. Babich. I think there are additional studies that could be incorporated.
And I guess we can provide those as part of our response to that charge question, maybe point the EPA to these citations.
We included those in the write-up.
Okay, great. Okay, Dr. Cobb?
This a very quick follow-up to Dr. Ottinger's comment. And this topic of female reproductive longevity came up in our last review, not of phthalates, but of other, I think it was 1,3-butadiene, where this was a serious consideration in the magnitude of effect. So this point is not exclusive to phthalates, although that's what we're talking about here today. That is all I had to say.
Okay. Any other comments from the committee? Okay, any clarifying questions from EPA?
Yes, John Mulran from US EPA here. So I have two, maybe three clarifying questions. When you were referring to the POCAR studies, it wasn't clear in your verbal relaying of that if you were talking about POCAR 2012 or 2017. So just want to make sure that that we're understanding from your report, because we had used POCAR 2017, they didn't look at all the same endpoints, but I think they used similar dose levels. And a lot of what we saw in 2012 was not replicated in 2017. So we used that as evidence that it wasn't replicatable. So in your discussion of POCAR, I just want to make sure we're understanding which of the two studies we're talking about. Other question that I had was when you were having Dr. Martinez was discussing the inhalation studies, it wasn't clear to me if we were kind of jumping ahead to the other charge question about the inhalation, or if we were specifically the strength of the inhalation studies, or if we were specifically talking about the evidence in the Ma et al. 2006 study that was an inhalation study, but in female rats and showed maybe some effects on sexual maturation, reproductive endpoints. So just wanted clarity on what you were wanting us to do with that, which specific evidence it was, and if it's related to the female reproductive tract or if it's separate in discussing inhalation.
Hi, this is Dr. Martinez. I don't have that clear in my discussion, but I will definitely add it as a comment and make sure that we clarify that.
Okay.
Thank you.
I think that's all I had. So thank you for the response.
Okay, Dr. Cobb?
This is just maybe to help EPA. Do any of the discussants know which reference EPA was asking about, whether the comments were specific to one of those references or the other? And if not, that's fine, but any additional lead time we can give the agency to start shaping the revisions to the risk determination will be helpful for them.
Well,
Looks
hi.
like no.
We have a few. I could clarify real quick. So I did switch gears on POCAR a couple of times because the body weight changes were the 2012, and that those were the transient effects, but the multi-generation effects were the POCAR all 2016. So we do have it clear in the write-up. I just didn't bring up the years in my discussion. I apologize.
This is George Cobb. No apologies necessary. You're trying to juggle a lot of stuff. And sorry to interrupt, Dr. Gentry, but yeah.
No, that's fine. That's fine. Does that add some clarity for now?
Yes, I appreciate it and totally understand that you're looking at a lot of information. And so I just wanted to have it noted for the record, just so to make sure it's clear in your report. Yeah, so
Okay.
To help us along. All right, thank you.
All right. Thank you. And thank you, Dr. Martinez. I guess are there any other comments, questions around this charge question? Okay, if not, I guess we will move to question 5B. If EPA will read the question into the record.
Okay, charge question 5B. In sections 4.2 and 4.3 of the draft non-cancer human health hazard assessment for DEHP, EPA has preliminarily selected the NOEL of 4.8 milligrams per kilogram per day, a human equivalent dose or HED of 1.1 milligrams per kilogram per day, as the POD to estimate non-cancer risk from oral exposure to DEHP for acute, intermediate, and chronic durations of exposure. The POD is based on the NOEL from a multi-generation reproductive toxicity study in which reproductive tract malformations were observed in male offspring at 14 milligrams per kilogram per day, as indicated in the study by Blystone et al. 2010 and Theramune Research Corporation 2004, and the study by Andrade and Grande et al. 2006. With a similar NOEL, 5 milligrams per kilogram per day, and LOEL, 15 milligrams per kilogram per day. along with 13 additional studies reporting effects on the developing male reproductive system, consistent with disrupted androgen action in phthalate syndrome at low L's in a narrow range of 10 to 15 milligrams per kilogram per day. So the charge question is, please comment on the strengths and uncertainties in the selected human equivalent dose, including EPA's selection of co-critical studies and the weight of scientific evidence from the studies supporting a refined consensus low L.
Okay, thank you. Let's see, I will turn it over to Dr. Heiger-Bernays as our lead discussant for this charge question.
Okay, thank you very much, and thank you to the co-discussants. Summary, EPA has identified, reviewed, and documented relevant studies for DEHP, seeking to identify, quote, consensus, unquote, no L's and low L's for use as the point of departure. EPA did not apply benchmark dose modeling for estimating non-cancer risks of DEHP and instead identified a no observed adverse effect level as the POD for male reproductive toxicological endpoints. The review of data and outcomes of DEHP exposure to the development and function of the male reproductive system is thorough, with reasonable interpretations of the findings across the studies. And the selection of 1.1 mg per kg per day is supported by a suite of studies that revealed effects at levels as low as 1 mg per kg per day, which related to reduced normal sperm and decreased sperm count. Other studies reported damage to the developing male reproductive system at 10 mg per kg per day. As such, the HED is reasonable and is consistent with reported NOEL concentrations identified by other agencies, including the U.S. Consumer Product Safety Commission's Chronic Advisory Panel and the National Research Council. The resulting POD should be protected for acute, intermediate, and chronic durations for male reproductive effects. It is noted that there are other lower NOEL low-L pairs for other toxicological endpoints. The methodology for estimating the benchmark dose using meta-analysis of appropriate studies was described by the National Academies of Science, Engineering, and Medicine. However, the results of the benchmark dose for DEHP are being considered only to support the selected NOEL. Specific comments. Evidence demonstrates that DEHP acts as an endocrine disruptor, and accordingly, even relatively low doses are likely to have long-term adverse effects, especially if exposure occurs during sensitive developmental periods in the life cycle. Studies presented in the draft non-cancer human health hazard assessment for DEHP support the HED based on the finding of multiple studies, as well as the selection of measurement endpoints used to determine adverse effects. The uncertainties with some studies are justified, and other studies are sufficient to establish the dose response to a low L range of 10 to 15 mg per kg per day. It is also appropriate that only DEHP treatment effects are considered, and the combined effects of exogenous steroid hormone treatments to distinguish prostate and other steroid-sensitive responses are eliminated from consideration. Although changes in sensitivity to steroid hormones may alter with pre- and perinatal exposure to DEHP and other compounds, it is more important to establish the low L for biological actions. Further studies may be needed to establish lifelong effects that alter the sensitivity to exogenous steroid hormones and endocrine disrupting compounds, as well as mixtures in the environment. The multi-generational studies are very large, those in the document, showing effects supportive of the POD and HED. There are some limitations in the sampling and data collected, and EPA chose not to consider evidence from studies related to other adverse health outcomes beyond male reproductive effects, including female reproductive harm, nutritional, metabolic toxicity, liver toxicity, or cardiovascular kidney toxicity. Of these, at least 20 studies reported NOELs or low Ls below the 4.8 mg per kg per day, suggesting these endpoints may be more sensitive indicators of DEHP toxicity than male reproductive toxicity. Nonetheless, EPA did not consider them in the point of departure derivation, and in many cases because study outcomes were also not observed in other talks or epidemiologic studies in the scientific literature. The study relied upon by ATSDR, which was the Zhang study 2014, to derive a chronic minimum risk level for DEHP, was dismissed for lack of replication in other rodent studies, and EPI studies identified a NOEL of 0.04 mg per kg per day for delayed female germline progression. Note the comments in question 5D, while the single dose study is not suitable for benchmark dose modeling, it does provide evidence of sensitive outcome that should be part of the evidence in support of POD selection. Several studies provide evidence of DEHP toxicity, as already mentioned, at lower doses. EPA should have incorporated them into benchmark dose modeling in our dose response assessment to ensure conclusions that are reflective of the full body of evidence. Specific comments read the use of benchmark dose analysis. EPA concludes that the benchmark dose analysis produces a higher POD than that from the NOEL-LOEL approach, yet this is insufficient justification for using the NOEL. A more scientifically appropriate justification would seem to be the difference in study designs and endpoints, rather than the fact that the Blystone NOEL is lower than the meta-analysis BMDL5s. The Blystone study was a 3-generation study, longer duration of exposure, which may be more appropriate for chronic effects, and it reported reproductive tract malformations, which are effects of a higher biological order than reduced testosterone production. Potential limitations of the NOEL-LOEL approach as compared to the BMD modeling approach for the determination of PODs, as outlined in the benchmark dose technical guidance, EPA's benchmark dose technical guidance, have not been considered, and there may be reasons, such as consideration of the variability in all of the available data as part of the BMD approach, that support the use of the BMDL instead of the NOEL-LOEL. Further, the BMD approach, not a NOEL-LOEL approach, is relied upon for the meta-analysis. EPA justifies the use of a 4.8 mg per kg per day consensus NOEL from Blystone and 10 mg per kg per day as a consensus LOEL because of similarity with co-critical studies, and 2, the lower, more sensitive POD using this approach than using meta-analysis and BMD modeling of several studies reporting testicular testosterone as the response. While there is consensus that 10 mg per kg per day causes toxic effects, a BMD may be a more precise POD than the LOEL. With respect to the BMD analysis presented in section 4.2.4, EPA doesn't adequately justify why data from Blystone 2010 wasn't used to conduct BMD modeling. Some additional comments. EPA does not state whether the review of developmental reproductive effects includes studies measuring the rate of testosterone production, such as Hannes et al. 2011, important for providing a more complete review of DEHP's mode of action. In lines, exclusion of prostate and LABC weights because they were not histologically examined seems arbitrary and needs justification. In other sections of the report, EPA says that they will apply the POD derived from oral exposure to dermal and inhalation exposure routes. This is limited by a lack of knowledge of dermal and inhalation kinetics. Presumably, metabolism to the active monoester is slower when absorption happens at dermal or perhaps pulmonary sites where the diester would be taken up into general circulation before ester cleavage in the liver. As a minor weakness in the report, not the analysis, the Wang et al. 2017 study was not considered, but it is unclear why it is discussed here because it focused on cancerous or precancerous lesions in the prostate. And in lines 4880, again, the more sensitive NOEL of 3 mg per kg per day provided by the study by Christensen et al. 2010 is more of a reflection of lower dose selection, NOEL and LOEL are always a function of dose selection. If 3 mg per kg per day is in the same plausible range as 4.8 to 5 mg per kg per day, and it's significant, why does it not become the NOEL? So for recommendations, provide citation or reference to support the concept of the quote consensus NOEL, quote, end quote, and provide clear justification for dismissing male reproductive endpoints in selection of the NOEL-LOEL pair, or NOEL-LOEL. EPA should follow its own well-established guidance and recommendations of NASEM and the SACC, which is a repeated SACC recommendation, by conducting benchmark dose modeling. 3, consider performing the BMD analysis of the Blystone et al. Study rather than using the NOEL from the study as the point of departure. 4, consider whether the longer duration of exposure in the Blystone et al. 3-gen study than in the numerous short-term studies and the endpoint of reproductive tract malformations, which are a higher order effect than reduced testosterone biosynthesis, contribute to EPA's confidence and therefore justification for using the Blystone study to derive the POD rather than the meta-analysis and BMD. 5, extract and use existing data or require determination of rate of metabolism of DEHP to MEHP for dermal and inhalation exposure routes. 6, provide additional evaluation to determine the potential limitations and or uncertainties in relying upon a consensus NOEL-LOEL approach when the BMD approach is the preferred approach for the meta-analysis. Table 4-1 in the draft non-cancer human health hazard assessment for DEHP is very useful. Other endpoints that are responsive and described in detail above should also be presented separately or as part of this table. And in lines 4631 through 4653, the criteria for study selection are for non-cancer health points in general. There needs to be a segue or conclusion to support the focus on male reproductive development, as well as some criteria for selection of studies on male reproductive development. Generally, studies included exposure during the, quote, critical window, end quote, gestational days 15 to 21 should be one criterion. And that is what I have.
Okay, thank you, Dr. Heiger-Bernays. We'll go to the associate discussants, and I'm one, and I think you captured all my comments. Thank you. Dr. Ottinger?
Great job. You captured everything for me. Thanks.
Okay, Dr. Babbage?
Yeah, the same here. All of my comments were captured.
Okay, and Dr. Spade?
I agree. Excellent summary, and all of my comments were captured.
Okay, anyone else on the SACC have any comments or questions? Okay, if not, EPA, do you have any clarifying questions?
Yes, just one. It's John Allred, US EPA. So when you're recommending doing BMD modeling as an option instead of the NOEL-LOEL approach, is that limited to just the reproductive tract malformations in the Blystone 2010 study, or more broadly? I'm asking because
Sorry, yes.
BMD modeling for the the fetal testicular testosterone, but not
for the Blystone, and not including the other endpoints. Is that correct? Yeah.
Okay. So Blystone, but other endpoints beyond the reproductive tract.
Definitely Blystone, and I'll need to, I think, discuss and get back to you with regard to inclusion of the other endpoints. But I do think that, let me not misspeak. I will get back to you about whether that includes the other endpoints as well.
Okay. All right. Thank you. That's all
I
from
think
EPA.
Dr. Cobb is going to tell me I can't do that.
I am not. I am going to suggest that in previous SAC reviews, I think this calendar year, the committee suggested using the BMD modeling when the data supports it. And I know that's up to interpretation and it's beyond my true full understanding, but if the data are available to use that rather than a Noel.
Noel.
Yeah. And so that's just my insertion there.
Point well taken. And I think that we'll draft the response to reflect that.
Okay. Thank you. Any other comments or questions before we move forward? Okay, I will turn it over to EPA to introduce charge question 5C1. 5C1.
Okay, I'm just making sure I was on the right question. Charge question 5C. Okay, in the draft non-cancer human health hazard assessment for DEHP, EPA discusses the health hazards identified via the inhalation route of exposure in section 3.8. EPA has preliminarily determined the weight of scientific evidence does not support the use of hazard data from available animal inhalation studies for quantitative use in determining an inhalation POD, section 3.9. EPA did not consider any of the 5 inhalation studies in animals to be suitable for quantitative derivation of a POD due to limitations and uncertainties related to exposure characterization, inconsistencies in the occurrence, temporality, and directionality of many of the effects, and questionable adversity for effects considered to be minor and/or transient. Given the lack of specific inhalation epidemiology data and uncertainties associated with the animal toxicity studies, EPA did not consider these studies quantitatively for determining an inhalation POD. So charge question 5C1. Please comment on the strengths and uncertainties of the supporting data.
Okay, thank you. And I will turn this over to Dr. Fox as our lead discussant for this question.
Great. Thank you, Dr. Gentry. This is Mary Fox with the response to 5C1. So some general comments. Lack of epidemiology data is not a reason to discard animal data. And this refers to some of the wording of the question. Lack of data does not imply a lack of exposure or effect. Lack of data indicates the need for EPA to require more data of petitioners for the conduct of this review. The committee noted the agency's approach to reviewing existing assessments for DEHP to identify sensitive and human relevant hazard outcomes associated with exposure to DEHP to assist in the synthesis of available literature. Also, existing assessments were used to identify key studies to establish points of departure. A lot of repetitive text from those previous assessments was used that makes the document voluminous. So there may be ways to edit that. However, the document states on line 629 of page 21 that the assessment includes scientific literature up to June 2020. This may be adequate, but a quick look at PubMed from 2020 through 2025 in June 2025 lists at least more than 121 papers for DEHP. It's unclear whether they would influence the assessment, but it would be good to review those titles and abstracts to make sure that any new and important information can be included. And section 3.9 was well written and provided a good summary of the studies reviewed by the agency. The committee agreed with the agency's decision not to use the DEHP epidemiology studies quantitatively for dose response assessment, in line with several other agencies, and agreed with the approach of evaluating studies with low ALs less than or equal to 20 milligram per kilogram day from the ATSDR assessment as a good starting point. Some limitations and uncertainties. Further explanation is needed regarding EPA's interpretation that effects from inhalation exposure were unrelated to DEHP, and this may relate to the Larson et al. 2007 study. The EPA has misinterpreted the experimental procedures by Kurahashi et al. 2005 and Ma et al. 2006. In the draft non-cancer assessment of DEHP, the agency cites deficiencies in reporting particle size and concentration. However, a closer look at the experimental procedures indicates that animals were exposed to a vapor rather than to an aerosol. Both publications, apparently from the same laboratory, state that DEHP was heated to generate a vapor, and here there's a quote from the Kurahashi paper. DEHP was contained in a flask and vaporized with bubbling glass-filtered air. The base of the flask was immersed in a temperature-controlled oil bath maintained at 90 degrees C for the low-dose DEHP and 130 degrees C for the high-dose DEHP. Thus, no aerosol was generated except for the potential of an incidental mist, the presence of which the investigators did not test for. In addition, the agency's concern about using whole body exposure may be moot, given that an aerosol was not generated. It is possible that heated vapor of DEHP could have cooled on the fur of the animals, leading to oral or dermal exposure. But because airborne concentrations were determined using gas chromatography, it seems unlikely that significant condensation of DEHP occurred. These clarifications regarding exposure do not obviate the concerns regarding the biological data of Kurahashi et al. And Ma et al., which appear to be inconsistent with experimental data from other investigators. Uncertainties in study methods are minimal in comparison to the uncertainty from having no inhalation data. If EPA wants to consider using ingestion as a surrogate for inhalation, a comparison of inhalation and ingestion-derived HEDs would be informative for this and approaches to other assessments. It should also be noted that the inhalation route of exposure does not place the toxicant in the bloodstream in the same fashion as does ingestion. This would cause differential exposure to parent toxicants and transformation products. Regarding the supporting data on inhalation exposure and relevant in vivo effects, the agency did a very good job in summarizing the information and putting it into perspective. There is a possible area of confounding which could explain the different results from the Kurahashi et al. And Ma et al. Reports from other referenced studies. From the descriptions reported within these publications, Kurahashi and Ma, this may have been one study split into a male publication and a female publication. The materials and methods are written in such a way to suggest the animals were all exposed together in the same chambers, which is likely based on the commoner's experience and the expense of performing these kinds of inhalation studies. Therefore, the presence of males and females together might have impacted the hormone-related results. From the existing data, DEHP inhalation exposure is relevant and important for workers, non-worker adults, and children. Noting a new paper that identifies SVOCs in air in rooms where babies and children sleep. This is Vezafar et al. 2025. The authors show that under the described settings, the main uptake of both of two phthalates, DEHP and DEP, was through inhalation. Because of this important route of exposure, not including it in some way would result in a significant underestimation of exposure. As noted above, the inhalation route of exposure does not place the toxicant in the bloodstream in the same fashion as does ingestion. The VASAFAR study estimates metabolite concentrations of MEHP and MEP, and EPA should consider the estimates from this study and from others, the Westler et al. 2015, Morrison et al. 2016, and from other studies identified and reviewed by EPA, to do a bounding calculation to demonstrate that the root-to-root extrapolation to derive the point of departure from the oral data doesn't underestimate. And there's a clarification requested for the agency's interpretation of the Larson et al. 2007 study. The interpretation the agency includes in the document differs from the author's stated conclusion. And so some just sort of rectifying those apparent discrepancy is requested, specifically related to Figure 3, which shows that at the highest DEHP dose, there were statistically significant increases in cell counts of eosinophils, neutrophils, and lymphocytes. If those changes in cell counts are not biologically relevant, this should be explained in the text. And we have several editorial comments about repeating information, and those will be included in the written. And we recommend review the DEHP literature published since June 2020 to ensure nothing important or influential was missed. Clarify and revise the interpretation of the Kurahashi et al. And Ma et al. Studies, considering the committee comments. And conduct a bounding calculation to demonstrate that the root-to-root extrapolation to derive the inhalation pod from the oral data is not an underestimate. And that's what we have.
Okay, thank you, Dr. Fox. Let's check with the associate discussants. Dr. David.
No additional comments, thank you.
Okay, Ms. Jenkins.
No additional comments from me. Thank you.
Dr. Wolf.
No, we're well represented. Thank you. Good job.
Dr. Heiger-Manez.
Thank you. That was really good and covered my comments. Thank you.
Okay, anyone else from the SACC have comments? Okay, EPA, do you have any clarifying questions?
Yes, thank you, John Allran, US EPA. When you were referring to the apparent discrepancy between the way that the agency and the authors interpreted the Larson 2007 study, and you cited changes at the highest concentration in eosinophils and other leukocytes, was that in the experiment that had co-exposure to ovalbumin to test sensitization, or was that in the initial experiment that was just an acute dose, just to DHP alone?
You know, I am not sure, so we will have to clarify that for you.
Okay, great. That's all from the agency. Thank you.
All right. Thank you. Any other questions, comments around this charge question? Okay, if not, turn it over to EPA to introduce charge question 5C2.
That's right. Okay, John Allran, US EPA. Charge question 5C2. Please comment on EPA's decision to perform route-to-route extrapolation from the oral POD to derive an inhalation POD. So I guess that's been read into the record now. I know we had discussed that some. I'm not sure if the committee has anything further that they want to discuss regarding route-to-route extrapolation.
I think so, and Dr. Fox will also lead that discussion.
Yes, great. So Mary Fox reading in committee comments for 5C2. So the committee in general supports the use of rich route extrapolation to address the inhalation risk based on the oral exposure studies, as those data were the most robust, as pointed out in the prior comments and discussion of the limitations of the inhalation studies. However, rich route extrapolation of a POD from oral exposures to a POD for inhalation exposure to DEHP is inappropriate because enzymatic activity in the GI tract is not the same as in the lung. And there's a citation, Ito et al., 2005. Although we note that White et al., 1980, does not discuss organ differences in lipase activity. In the gut, hydrolysis of DEHP is an integral first step in absorption, and this from section 2.3, which would not occur in the lungs because of the reduced or absent in the case of primates lipase activity. And hydrolysis is a necessary step for biological activity. The agency needs to reconsider its approach to inhalation, vapor, or aerosols as a route of exposure unless the extrapolation can take into account differences in hydrolysis in the gut and lungs. And EPA discusses studies from the ATSDR 2022 toxicological profile that suggest differences in absorption across routes. Perhaps that would be informative in reconsidering the route extrapolation. And so comments that were provided in 5C1 related to the Vezafar et al. 2025 study are also relevant here. And this has to do with using these studies to do the bounding calculation. So I won't read through all of that again. So we have it already on the record. And so the main recommendation here is to reconsider and refine the route-to-route extrapolation, considering metabolism and absorption differences. And that's what we have.
Okay, thank you, Dr. Fox. We'll go to the associate discussants, of which I'm one, and you incorporated all of my comments. Thank you. Let's see, Dr. David.
No additional comments. Thank you.
Dr. Wolf.
Nothing to add. Thanks.
Okay. Dr. Heiger Bernays.
Nothing to add. Thank you. Good summary.
Okay. Anybody else from the committee? Okay. EPA, any clarifying questions?
John and US EPA. No clarifying questions from EPA. Thank you.
Okay. Let's see. Let's see. We will now move on to charge question 5D.
Okay, John Oran, US EPA, charge question 5D. In section 4.3 of the draft non-cancer human health hazard assessment for DCHP, EPA has preliminarily selected a human equivalent dose, or HED, of 2.4 milligrams per kilogram body weight per day, equivalent to a NOEL of 10 milligrams per kilogram per day from the Lee et al. 2016 study, based on effects on the developing male reproductive system consistent with a disruption of androgen action and phthalate syndrome, for assessing risk from acute, intermediate, and chronic duration exposure to DCHP. Please comment on the strengths and uncertainties in the selected acute/intermediate/chronic HED for DCHP.
Okay, thank you. And I will turn it over to Dr. Spade as our lead discussant.
Okay, thanks. The choice of reduced fetal testosterone production as the endpoint to set the point of departure and human equivalent dose for DCHP was supported by multiple studies and consistent with the adverse outcome pathway presented in section 3.1 of the draft non-cancer human health hazard assessment for DCHP, which depicts phthalate-associated developmental effects on the male reproductive system termed phthalate syndrome. Phthalate syndrome is a well-characterized suite of adverse physiological effects that are relatively consistent outcomes from exposure to phthalates supported by a large body of literature. Prior reviews have established that the fetal window of exposure is the window of greatest sensitivity for phthalate syndrome effects. DCHP causes the phthalate syndrome effects as described in section 3.1 in publications such as Fur et al. 2014. In addition to phthalate syndrome, there are additional documented adverse effects of DCHP, including altered liver function and oxidative damage. The human equivalent dose selected by EPA was based on a study by Lee et al. 2016, which was conducted in fetal Sprague Dawley rats. The Lee et al. Study reported a NOEL of 10 milligram per kilogram day for reduction of fetal testicular testosterone. Of the 12 DCHP studies reviewed for this analysis, which are presented in Table 3-1, only 3 reported a NOEL, and the Lee et al. NOEL was the lowest value. The 10 milligram per kilogram day LOEL in Lee et al. Was supported by additional mechanistic data in the paper related to phthalate syndrome, including altered Leydig cell phenotype and reduced expression of steroidogenic genes, including HSD17 beta 3, which is responsible for the conversion of androstenedione to testosterone at 10 milligram per kilogram day. These effects are consistent with knowledge of the phthalate syndrome and the AOP presented by EPA. There were several uncertainties. First, the animal studies reviewed for DCHP used various rodent models, dose ranges, diet or gavage treatment administration, and timing of DCHP exposure, which introduces uncertainty about NOEL and LOEL selection. However, a 2-generation study with chronic dietary treatment over a range of doses reported a NOEL of 17 milligram per kilogram day with effects on AGD in postnatal day 4 males, nipple retention in F2 males, and diminished spermatogenesis in adults at the NOEL of 17 milligram per kilogram day and LOEL of 85 milligram per kilogram day, which provides corroboration for the selection of a POD in the 10 to 20 milligram per kilogram day range. The study by Lee et al. Revealed effects with a dose as low as 10 milligram per kilogram day, which had adverse developmental effects supported by molecular mechanistic data, albeit with greater variability and uncertainty in those measures. Second, EPA identified the lack of an appropriate PBPK model for interspecies extrapolation and the lack of empirical data to compare human and rat internal dose from oral exposure as limitations. In lieu of a PBPK model or specific data to scale rat exposure to humans, EPA used allometric scaling and reduced the UFA from 10 to 3, consistent with EPA guidance and as described in detail in Appendix D. The committee's overall recommendation is that EPA should proceed with the human equivalent dose of 2.4 milligram per kilogram day based on the LOEL dose of 10 mg per kg day in the rat in the selected study by Lee et al. There was one discussant who expressed that the selected acute, intermediate, or chronic HED for DCHP may not be appropriate and applicable, and that a POD based on the NOEL of 17 milligram per kilogram day in Hoshino et al., the 3-generation study, would be more appropriate for the following reasons. In the Lee et al. Study, DCHP significantly inhibited testicular testosterone at levels of 100 milligram per kilogram per day and above. So in terms of statistical significance for testosterone, 100 milligram per kilogram day was the lowest dose at which statistical significance was achieved. Although changes in gene expression at 10 milligram per kilogram days were significant and supported hazard identification, Without a detailed discussion on how these genes impact the AOP, a valid postnatal endpoint would be preferable. DCHP was tested in a well-performed 2-generation study in rats. The NOAEL for the developmental effects was 240 ppm or 17 milligram per kilogram day based on decreased anogenital distance. The paper by Erdogan, Abab et al. 2013 reported a LOL of 20 milligram per kilogram day for abnormal sperm and testicular histopathology in adult rats following exposure on GD6 to 19, but this was the lowest dose tested, and so it also supports selection of a POD of 17 milligram per kilogram day. And that is the summary from the charge group.
Okay, thank you. Thank you. Let's go to the associate discussants, Dr. Ottinger.
Great job. You captured everything. Thank you very much.
Okay, Dr. Fox.
Nothing to add.
Okay. Dr. Martinez.
Hi, I think you did a good job and covered all my points. Thank you.
Okay, Dr. Hager Bernays.
Same here. Nice job. You captured everything. Thank you.
Okay. Anyone else from the SACC? Any clarifying questions from EPA?
Hi, this is John Alrin, US EPA. No clarifying questions from EPA. Thank you.
Okay. Thank you, Dr. Spade. And I think with that, we're running ahead of schedule a little bit, and we're going to take a break. Dr. Kamal, how long of a break are we going to take?
Well, we can take 15 minutes since we are ahead of schedule.
Okay. All right. Well, everyone, thank you we've had some great lead discussants and associate discussants and great summaries. And let's take a break and reconvene in about 15 minutes when Dr. Cobb will take over.
Okay, welcome back, everyone. This is near the end of our second day, and a couple of housekeeping issues. First is that, especially for the folks with EPA contractors and those that are going to be reading things into the record, we are likely to skip 5F and go to 5G in our next as our next charge question after 5E. So I want to give you a little heads up on that, and then we can proceed to 5E. And if EPA will read that question into the record, please.
Okay, John Alran, US EPA, charge question 5E. In section 4.3 of the draft non-cancer human health hazard assessment for BBP, EPA has preliminarily selected an HED of 12 milligrams per kilogram per day, equivalent to a NOEL of 50 milligrams per kilogram per day. Based on effects on the developing male reproductive system, consistent with the disruption of androgen action and phthalate syndrome observed across several studies, including studies by Till et al. 2004, Mod et al. 2014, Fur et al. 2014, and ASO et al. 2005. For assessing risks from acute, intermediate, and chronic duration exposure to BBP. Please comment on the strengths and uncertainties in the selected acute/intermediate/chronic HED for BBP.
Thank you. And now we turn to our discussants, and Dr. Gentry is our lead discussant.
Okay, thank you. Can you hear me okay? I'm experiencing some delays in technology.
So we can hear you fine. Your video is lagging a little bit, but that is fine. Thank you.
Okay. Okay, there are 4 co-critical studies that were selected by EPA that support a consensus low AL of 1,000 mg per kg per day, which is Ahmad et al. 2014, Fur et al. 2014, Azo et al. 2005, and a no AL of 50 mg per kg per day, which is from the Till et al. 2004 study. The endpoints of concern were effects on the developmental reproductive system in the male rat that were consistent with the disruption of androgen action and phthalate syndrome. This is a strength as it relied upon the results of multiple studies that reflected both prenatal and postnatal exposures and dosing and a range of effects consistent with disrupted androgen action phthalate syndrome to estimate an HED of 12 mg per kg per day based on the NOAL reported by Till et al. 2004. However, there are 2 major concerns. One is the confirmation that the HED is supported by existing data for the developing male reproductive system, androgen action and phthalate syndrome. And 2, whether additional published studies continue to support only the androgen action phthalate syndrome, or whether the POD from newer and controversial studies such as Gray et al. 2021 can be used to refine the selected HED. Based on the use of the studies identified prior to 2019, the derivation of the HED using the no-AL, low-AL approach is reasonable. However, EPA did not follow its own and the SACC's recommendations to use a BMD approach to capture the full suite of data in derivation of the HED. In addition, studies published in the past several years support adverse effects on male reproductive developmental associated with BBP exposure for phthalate syndrome, as well as additional tox, and mechanistic studies that provide evidence of effects that may occur at lower PODs. Further, for the meta-analysis, different studies than those considered for the no-AL, low-AL were considered for benchmark dose modeling. This would be Fur et al. 2014, How to Sell et al. 2008, and Gray et al. 2021. The scientific rationale for the focus on these studies is largely based on the consistency with recommended no-ALs, low-ALs from multiple regulatory authorities, including USC, PSC, Health Canada, ECA, NICNAS, and EFSA, which is in Table 1-1. EPA's conclusion to focus on effects of BBP on the developing male reproductive system as the most sensitive endpoint is also consistent with the NASEM 2017 approach. The NOEL for the cited studies, which is in Table 4 of the draft non-cancer human health hazard assessment for BBP, varied across the studies and was determined based on a variety of endpoints that are associated with Phthalates syndrome. As such, there is variation in the NOEL and NOAL values that range from 11 mg per kg per day, which is the NOEL, to 250 mg per kg per day, which is the NOAL. The highest values are associated with non-endocrine endpoints, specifically physical characteristics including cryptorchidism. These endpoints are downstream outcomes that are generally not as sensitive as testicular endocrine responses. As explained in the text of the draft non-cancer human health hazard assessment for BBP, there are reasonable rationale presented for selective specific studies for deriving the POD and HED. The studies reinforce the selection of the lower HED based on the functional testicular responses associated with gestational exposure. Some of the studies are also multi-generational, and these include the Azo et al. 2005 and the Till et al. 2004, which suggests a comparable no-AL, low-AL for these endpoints following chronic exposure. It should also be noted that the NOEL for the cited studies in Table 4-1 varied across the studies and was determined based on a variety of endpoints that are associated with Phthalates syndrome. When Phthalates syndrome is the endpoint selected, there is variation in the NOEL and NOAL values, as mentioned before, that range from 11 to 250 mg per kg per day. However, EPA does not recognize or consider other endpoints based on the literature from the early 2000s, and by inclusion of these endpoints, refinement of the NOAL-based HED is possible. At the very least, recognition of these other endpoints needs to be included in the rationale. So our recommendations are reliance upon multiple authoritative reviews of the available data for BBP and drawing conclusions regarding studies to be relied upon for EPA as a strength and demonstrates consensus with other reviews of the relevant data for BBP, as long as there are no new studies to challenge that conclusion. The endpoints of concern are also consistent with endpoints recommended by the SACC in a previous review of the approach for phthalates. If certain studies are relied upon to develop a no-AL, low-AL as the POD for recommendations for a single phthalate, the uncertainty in relying on BMD results and different studies for the meta-analysis should be discussed. Further, the data from Gray et al. 2021 should be considered, as well as endpoints with a no-AL, low-AL lower than those from Till et al. 2004. And just one specific comment around lines 416 to 420. This sentence should specify that the sexual differentiation or masculinization of the gonads occurs during this time and does not refer to sexual differentiation of the hypothalamus and neuroendocrine systems. And that is the summary of our comments.
Excellent. Thank you very much for that. And now we can go to our associate discussants. Dr. Fox?
No, my comments were captured. Thanks, Dr. Gentry.
Dr. Heiger-Bernays?
Same here. Thank you for the summary. Nothing to add.
Dr. Babbage?
No additional comments.
Thank you. Dr. Ottinger?
No additional comments, and thank you very much, Dr. Gentry.
All right. now we can go to the remainder of the committee, and I see that Dr. Rowlands has his hand raised. Dr. Rowland.
Yeah, hi, thanks. I just want to reiterate the differences between a syndrome and a disease. A syndrome is a collection of observations that may or may not, create a disease. And a disease has a higher threshold, and they're not the same thing. So I don't want this committee to start questioning the medical field to say we can decide what a disease is where they may not have done that yet. So it's very important that we make that distinction throughout this whole exercise and our decision. So thank you. That's all I want to say.
Thank you. Other comments from the committee? I actually have a couple of questions, and part of this is that so that we don't have problems writing the documents and that kind of thing. First of all, there was a mention of a Gray et al. Study being controversial. Was there a rationale for that being controversial? I didn't read through this non-cancer health hazard for BBP as extensively as I should have.
I think that comes out of EPA's discussion of that document. But don't let me misspeak. If the other discussants have clarity on that, please help me out.
I see Dr. Ottinger. Just feel free to chime in.
Yeah, there's no controversy about that study. It's very well done and very clear. The only thing that I raised in other charge questions was that it focuses on production of testosterone rather than testosterone content in the testis. And so therefore, it's actually, in lots of ways, a better measure of functionality. Beyond that, I don't know what would be controversial.
Okay, thank you. And just knowing that group, that I was surprised that it was termed controversial. Okay, the other question I had, and I think I know the answer, but want to clarify it. The selection of 50 milligrams per kilogram per day, was that some kind of a median or geometric mean of all of the different NOAELs, or was that a particular study that was selected?
That's the NOAEL from a particular study. It's from the TIL study specifically.
Right. Okay. And then, so there's an 11 value or something that was mentioned. There's a low value. That one was not selected.
Yes, I think that's correct.
Okay.
Yeah, and some of those I tried to be clear. The 11 is a NOEL, just a no observed effect level, and not adverse. The two they range up to, so that 11 was not an adverse, no effect.
Right. Okay, understood. And that is a distinction that I missed in your comment, and it probably is not something you omitted. It's something my brain just didn't hear through. So, thank you. Are there other comments from the committee? If not, we'll turn it over to EPA to see if there are clarifying questions regarding these comments.
Thanks, Dr. Cobb. This is Anthony Lez with EPA. We don't have any questions for clarifications at this time. I do have a comment, however. It sounded like the next charge question will be skipping over 5F and going to 5G. Is that the plan, or were you going from?
That is the plan, as long as it doesn't get you guys crosswise.
Yeah, we have a little bit of a concern with that, since for 5G, we're asking about our HED that we selected for dibutyl phthalate, DBP. And for DBP, that point of departure, HED, is based on the meta-analysis, which is why we put the meta-analysis question right before the DBP charge question. So I do think there's maybe, it might be wise to, discuss the meta-analysis and then go into the the DBP point of departure charge question, just because I think those two are so intimately linked.
Okay, that is fine, and we can do that tomorrow then. I think even though we're early today, perhaps the other the other discussant groups can write their work on writing their reports and getting the summaries in that fashion, and then we can adjourn for the day, and we will begin tomorrow at 10 a.m. Eastern, and I'll turn it over to Dr. Kamal for any closing comments that he might have.
So if we skip 5E and F, not sure about G and H. If we are ready, maybe we can start with them today, or I try to contact the lead discussants, but I didn't get a response yet. Have you tried to see if
I asked
G and
and
F?
no, I did not get a response, and I also told our committee we weren't going to go too far ahead, but H was one. I don't know. H was Dr. Spade, if he has.
Spade, mm-hmm.
Yeah,
I'm ready. I'm sorry. I didn't see your email, but I am ready if you want to move ahead.
Okay.
That would work. Again, as long as EPA doesn't think that we need to stay in the order.
No, I think we can go ahead to 5H, and even, if we get through 5H, go on to 6. Was just the concern with 5F and 5G being so closely tied together.
All right. Well, so let's go through 5H, and then that's probably going to be it for the day. So thank you.
Okay, Anthony Luz with EPA here. Charge question 5H. So as described in section 4.2 of the draft non-cancer human health hazard assessment for DIBP, EPA considered 3 options for deriving acute/intermediate/chronic HED for DIBP, including use of a NOAL. So that's option 1 in section 4.2.2.1. Use of a data-derived adjustment factor. So that's option 2 in section 4.2.2.2. And use of benchmark dose modeling of individual fetal testicular testosterone studies. So that's option 3, section 4.2.2.3. As described in section 4.3 of the non-cancer hazard assessment for DIBP, EPA has preliminarily selected an HED of 5.7 milligrams per kilogram per day. That's based on a BMDL5 of 24 milligrams per kilogram per day, based on benchmark dose modeling of decreased ex vivo fetal testicular testosterone production from Gray et al. 2021 for assessing risks from acute, intermediate, and chronic duration exposure to DIBP. So that's option 3. Please comment on the strengths and uncertainties in the selected acute/intermediate/chronic HED for DIBP.
Excellent. Thank you, Dr. Luz, for reading that in. And then Dr. Spade.
All right, so let me just make sure I'm not repeating Dr. Luz. So in the draft non-cancer human health hazard assessment for DIBP, EPA considered 3 options for deriving an HED for DIBP, as Dr. Luz just described, based on ex vivo fetal testosterone production, and those options are 1, the use of NOAL or LOAL, 2, the application of a data-derived adjustment factor, or 3, benchmark dose modeling. Those options yielded relatively similar estimates. However, differences in the HED derived from the 3 approaches showed possible underestimation with the NOAL LOAL approach, option 1, and much lower values using an adjustment factor, option 2. EPA considered the BMD modeling approach, option 3, to produce the highest confidence and least uncertainty. The committee's response is that there are several strengths to EPA's approach of using benchmark dose modeling to derive the POD and HED for DIBP. The BMD approach is generally preferred over the NOAL or LOAL method, and the use of continuous data for the BMD modeling here is appropriate. There were no concerns from the committee about that modeling approach. Although there was substantial evidence base consisting of 11 studies available for EPA's review, there were fewer studies of DIBP at lower doses, with most studies covering some portion of the dose range between 100 and 750 milligram per kilogram day. The lack of data at doses below 100 milligram per kilogram day makes it unlikely that a NOEL or LOEL could be used to generate a protective point of departure. EPA is justified in using BMD modeling rather than an adjustment factor because the adjustment factor approach would require comparisons of two different types of point of departure, a NOEL and a BMDL5, which creates an additional source of uncertainty. The calculation of human equivalent dose from the BMD analysis is consistent with EPA guidance, as is the reduction of the UFA from 10 to 3 for a total uncertainty factor of 30. The choice of reproductive developmental toxicity, specifically testicular testosterone for hazard evaluation, is supported by the data on the phthalate syndrome. Phthalates produce consistent, robust effects on testosterone production. The BMD based on data from Gray et al. 2021 should be viewed with high confidence given the quality of the paper and the known relationship of the modeled effect to the overall toxic mode of action. Testosterone production is an appropriate endpoint from which to derive intermediate and chronic effects as well as acute effects for two reasons. First, the study designs in question appropriately scale in utero developmental timing from animal models to humans so that the exposure window covers the sensitive window of development. The timing of the exposure must bracket critical developmental phases in which differentiation of testicular function occurs. Here, the dose response studies differ in the timing of treatment with windows including gestation day 6 to 20, 8 to 18, and 14 to 18. But all three, including Gray et al. 2021, conducted exposure that bracketed the key developmental window of susceptibility for this effect, the masculinization programming window, which occurs from gestation day 14 to 17 in the rat. Gestation day 14 to 18 in the Gray et al. Study scales to approximately 9 to 16 weeks of gestation, or the equivalent of 56 days in humans, with reference to the timing of testicular development. There's also evidence that the same or similar effects can be caused by short-term phthalate exposures in later gestation, but with greater sensitivity for germ cell effects and reduced sensitivity for anti-androgenic effects. Second, there are documented later life effects that follow from in utero phthalate exposures as described in the DIBP study by Salin, Fate et al., which is cited in table 4-5 in section 4.3, and also consistent with published evidence for dibutyl phthalate. The committee also identified several potential uncertainties. First, this appears to be an instance where Bayesian model averaging would be useful to develop a BMD5 or BMDL5 estimate that incorporates modeling of both the data from Gray et al. 2021 and Howdeshell et al. 2008. This capability was developed in past iterations of EPA's benchmark dose software, BMDS 3.2, but is currently not available. So that would be one area for improvement. A second source of uncertainty is extrapolation of oral toxicity data to dermal and inhalation exposure studies. EPA mentions this briefly towards the end of the human health hazard assessment for DIBP. The committee felt that while EPA has considered factors that alter dermal inhalation uptake relative to oral uptake, there does not appear to be consideration of factors that affect metabolic cleavage rates of the diester to the active monoester following systemic absorption from parenteral routes. The diester would presumably be cleaved after entering circulation, and it is unclear how much less efficiently that would happen or how much the Tmax for the monoester would be delayed relative to oral exposure. So this is not addressed in that brief section on dermal and inhalation exposures in the EPA report. The committee has three recommendations. Specifically, the committee recommends that EPA proceed with the benchmark dose analysis of Gray et al. 2021 as the basis for the point of departure. To support the selection of benchmark response level, EPA should provide a reference in the draft non-cancer human health hazard assessment to Appendix B of the cumulative risk assessment document, which provides justification for the use of BMDL5 as the POD. And essentially, to clarify a little bit. The committee is just sort of recommending that for consistency and transparency between different documents in the report, that justification is included here because, there have been discussions in several of the charge questions about the chosen benchmark dose level, whether BMD L5 or 10 or 1 standard deviation is the most appropriate BMR. And so we recommend actually including that information in this document. The committee recommends that EPA consider performing Bayesian benchmark dose analysis so that they can incorporate the data from How to Show et al. 2008 into this assessment. And finally, the committee recommends that EPA consider metabolism following dermal and inhalation exposure to improve extrapolation of oral toxicity data to the dermal and inhalation exposure routes to the extent possible. And that concludes the summary of the committee report.
Excellent. Thank you. Let's see if there are comments from any of the other discussants. Dr. Fox?
Thanks, Dr. Spade. My comments were captured.
Thank you. Dr. Heiger-Bernays?
No additional comments. Thank you.
All right. Thank you. Dr. Babbage?
I have no additional comments. It was a very thorough presentation.
All right. Thank you very much. Dr. Ottinger?
Likewise, thank you very much.
Right. And I see Dr. Rowland's hand is up.
Yes, thank you. Again, I'm going to reiterate that syndromes are defined by the presence of multiple related symptoms. A syndrome is a collection of symptoms that may or may not have some known cause. A disease has a known cause and specific symptoms, and while a syndrome is a collection of symptoms that may or may not have a known cause. Essentially, diseases are more clearly defined and understood in terms of their origins and progression. The data presented in this report does not demonstrate support of phthalate-induced disease, and therefore is in conflict with the medical community, i.e., that is the body of individuals who are qualified to practice medicine. That's it.
All right, thank you.
You bet.
Any other comments from the committee? Okay, seeing none, are there clarifying questions from EPA?
Thanks, Dr. Cobb. This is Anthony Lez with EPA. I'd like to thank the committee for their responses here. I just have one hopefully quick clarifying question. I think you had indicated that you'd like us to provide justification for BMR selection, so for the BMR of 5%. I think in the DIBP non-cancer technical support document, Appendix D provides our rationale for consideration the BMRs of 5, 10, and 40%, and ultimately is where we kind of land on our rationale for actually using the 5% as our point of departure. So I'm just curious, is there something else you're looking for in addition to that appendix?
No, and actually I may have, I'm not sure if I explicitly said Appendix D in my oral readout there, but yeah, I think the committee, that may have been more of an editorial comment than a scientific comment. I think we all sort of felt that we were digging for that justification. So either a single sentence calling out the appendix somewhere would probably suffice.
Thank you.
Yep.
And Dr. Rowlands, Dr. Rowlands, is your hand still up?
I'm sorry. Yeah, I keep forgetting to turn that thing on.
Do not worry.
No, it's not up. That's right.
Yeah, and Dr. Lutz, no necessarily response required here, but that comment about further justification, that's something that could be could be a broad spectrum comment about having to dig things out of appendices that if there was a sentence or two, it would really help us and it would help the broader audience once these documents are finally released as finals, to keep from having to dig through so many documents to get to the right place. So, and I know these are so complex that it's really difficult to do.
Yeah, no, completely understand. So even just a sentence kind of broken out from the paragraph. I think there's a cross-reference, but it's buried in, a large paragraph of text. So just breaking that out into its own paragraph. But yeah, I can see how that would be helpful.
Excellent. Thank you. Okay, I am hearing that maybe we have a response ready for charged question 6. What is it? 6A. And I'll check with Dr. Heiger-Bernays to make sure that I'm hearing correctly.
You're hearing correctly.
Okay. So just so that everybody's not waiting on pins and needles, I do not want to get too far ahead of ourselves on this because we'll run into all kind of downstream time problems later in the week and having to break in the middle of the day because people aren't ready yet. So,
well, the other thing is we're heading into cancer. Do we want to go there?
Well, I think we can start there, but we're gonna that's why I don't want to go too far into this. Part of the reason. So we can do 6A, and then that will have to be it for the day, so that we don't get too disjointed and get too far ahead where people don't have responses ready later in the week. So if EPA can read this into the record, then we can get a response.
Sure. This is Anthony Luz with EPA. We're in charge question 6. So in section 4.3.1.1.6 of the draft Cancer Human Health Hazard Assessment for DHP, DBP, BBP, DIBP, and DCHP, EPA has preliminarily concluded that the weight of scientific evidence indicates that the tumor triad, i.e. liver tumors, pancreatic acinar cell tumors, Leydig cell tumors, in rats is related to PPAR alpha activation following chronic exposure to DEHP. This preliminary conclusion is supported by inferences from hypolipidemic drugs that lower lipid levels in humans by activating PPAR alpha and also induce the tumor triad in rats, but not humans. So that's discussed in section 4.3.1.1.4. Additionally, EPA has also preliminarily concluded that DHP is not likely to be carcinogenic to humans at doses below levels that do not result in PPAR alpha activation, and that the non-cancer POD based on effects on the developing male reproductive system consistent with phthalate syndrome that was selected to characterize risk is expected to adequately account for all chronic toxicity, including carcinogenicity. It's assuming a threshold mode of action, which could potentially result from exposure to DEHP, and that's section 4.3.1.4. So charge question 6, part A. Please comment on the strengths and uncertainties of EPA's preliminary conclusion that the tumor triad in rats is related to PPAR alpha activation following chronic exposure to DEHP. In your response, please include discussion of the strengths and uncertainties of available data supporting key events in the PPAR alpha mode of action and the scientific rationale for a threshold approach for cancer dose response assessment.
Okay, this is Wendy Heiger-Bernays, lead discussant. I'll thank my co-discussants. The EPA is commended in its response to the recommendations of the SACC from July 2024 and for its work in summarizing the relevant studies demonstrating the activation of PPAR alpha by DEHP as an early event in the mode of action for hepatocarcinogenesis in rodents. Pancreatic acinar cell tumors, PACT, are related to the PPAR agonism secondary to the liver and would not be expected to be present at doses below which there's PPAR agonism. While EPA did not independently evaluate the extensive database of in vitro and in vivo genotoxicity studies of DEHP and its major metabolites, EPA agrees with the conclusions of other authorities that available data indicate that DEHP and its metabolites are not mutagenic, but there is some limited evidence that DHP may be weakly genotoxic, inducing effects such as DNA damage and or chromosomal aberrations. Taken together, a dose threshold activated nuclear receptor, PPAR alpha mode of action, and lack of strong genotoxicity supports the use of a nonlinear threshold approach for cancer risk assessment of hepatic tumors for DEHP. Specific comments: the studies presented by EPA in sections 4.3 strongly suggest that the tumor triad of hepatocarcinoma, pancreatic acinar cell tumors, and Leydig cell tumors are related to exposure to peroxisome proliferators, including phthalate esters. However, the evidence supporting activation of PPAR alpha as the initial key event is weak, especially when comparing activation of PPAR alpha by the monoesters, as in Bility et al. 2004. Bility and coworkers found that DBP, actually DMBP, was a weak PPAR alpha activator, which means that all three tumors would have been present following exposure only to high levels of DBP. This was not the case in NTP 2021. Only PAC tumors were observed, and Leydig cell tumors were only marginally above control levels. No hepatocellular tumors were observed. This does not imply that the agency's preliminary assessment that the tumor triad is associated with exposure to phthalate esters, however, only that the mode of action is not as clear for PAC and Leydig cell tumors. Thus, with any compound that is a peroxisome proliferator activated receptor alpha, PPAR alpha agonist, peroxisomes can increase in any cell or tissue, resulting in increased oxidative stress as a byproduct and possibly organ weight with enough expansion of peroxisome numbers. Health Canada states, however, the relevance of the hepatotoxic effects of phthalates observed in rodents is difficult to establish due to the species-specific differences in the peroxisome proliferation response, rodents being significantly more sensitive than humans to PPAR alpha mediated induction of peroxisome proliferation. The PACT arises secondary to PPAR agonism and appears to only occur at high doses. Any uncertainties or scientific deficiencies in those data to support the complicated mode of action are not needed to be filled, since the PACT response would not occur without PPAR alpha agonism. The constellation of tumors, regardless of tissue of origin, would be adequately prevented using the non-cancer POD as presented for individual and cumulative risk evaluation. Pancreatic acinar cell tumors are related to the PPAR agonism secondary to the liver and would not be expected to be present. Okay, so not likely carcinogenic would also be applicable for those pancreatic tumors. The strengths of this conclusion or the strengths of EPA's evaluation include the discussion of other possible mechanisms that may be involved. In addition, the discussion for how and why the other phthalates may not strictly follow the tumor triad is very relevant. With regard to weaknesses, the evidence is less clear and some uncertainty remains that mechanisms other than PPAR alpha activation may be involved in development of PACT and Leydig cell tumors. If available, what would strengthen the evidence for PPAR alpha mediated mode of action for the tumor triad is counterfactual data demonstrating lack of carcinogenesis or early biomarkers for cancer when PPAR alpha cannot be activated. Weaknesses are reflected in the cursory older review of the epidemiological evidence, in particular, the influence of exposures to phthalates and evidence of DEHP's carcinogenic effects, links to pathways including P13K, AKT, and the estrogen receptor as reviewed in Zhao et al. That is all I have.
Excellent. Thank you, Dr. Heiger-Bernays. And now we can go to Dr. David to see if he has further comments.
No additional comments. Captured very well. Thank you.
Excellent. Thank you. Dr. Wolf?
Yeah, I think the comments were captured. I just want to clarify a couple of things. I think at high doses with these PPAR alpha agonists, you can sometimes see oxidative stress, or frequently do see oxidative stress, and that can drive some genotoxic response. But again, it's still a dose-limited activity, in my opinion. And the other is that I think it'd be worthwhile in the sections of ruling out other modes of action to go back and look at the data, the lack of data on cytotoxicity and regenerative cytotoxicity and associated proliferation, or any other effects, because those should have been picked up in the histology of the shorter term studies. And quite frankly, you don't see that with PPAR alpha agonists, and particularly not phthalates. And so it's just pointing that out. So other mechanisms that, as you talk about here, I think they can be ruled out in the standard mode of action analysis. So I'd encourage the agency just to clarify that in their conclusions on this section. Thank you.
Yes, thank you. Dr. Martinez.
Hi, I don't have any further comments. She summarized it very well. Thank you.
Good, thank you. Dr. Rowlands.
Yes, thank you. So these syndromes we keep talking about are defined by the presence of multiple related symptoms. A syndrome is a collection of symptoms that may or may not have a known cause. So a mode of action, there is probably mystery at that point, although we do have some good evidence about the MOA here. A disease has a known cause and specific symptoms. Essentially, diseases are more clearly defined and understood, in terms of their origins and progression. The data presented in this report does not demonstrate phthalate-induced disease, and therefore it is in conflict with the medical community, which is the body of individuals who are qualified to practice medicine, not this committee. That's all.
With due respect, Dr. Rowlands, does that pertain to this question?
I have no idea, but it's true. So there you go. I'm putting it in the record. This is what I believe. We don't know that these symptoms actually progress to a disease. That would pertain to every question we're asking.
Dr. Aguirre, do you have anything else?
I do not.
Okay.
Thank you.
Thank you. Anyone else on the committee? I see Dr. Babbitt's hand.
Yeah, so I address, well, there's one paragraph in there, taken together a dose threshold activated nuclear receptor, PPAR alpha. I'm not sure exactly what that means. But what I wanted to say is in 6B, which I guess we'll get to tomorrow, I don't agree with the justification for assuming a threshold, but I'll talk about that tomorrow.
Okay. So was Dr. Babbage, was that a question for EPA or something you think they should clarify in the document?
Well, it's I'm talking about this paragraph in the summary of comments.
I'm sorry.
I'm not sure what that means. Maybe that can be clarified.
Dr. Babbage, can you point me to exactly where
so
you're?
Under summary, it's the last paragraph.
Okay, hold on. Okay. The question is taken together, right?
Well, the question is dose threshold activated receptor. What exactly is that?
Okay.
Maybe it's a typo.
I think it refers to, is it the dose at which there is a threshold for PPAR alpha activation, and that dose at which that occur? What?
So it looks like Dr. Wolf has his hand raised. Maybe he can.
I can help you with that. Yeah. So PPAR alpha agonism is a dose response activity. So without sufficient, without sufficient ligand you're not going to get that to happen, and then the downstream stuff doesn't happen.
Right.
Okay. So perhaps that language.
We'll tighten that language. So there's two pieces to that though, Dr. Babbage, right? One is the question about the meaning of the dose threshold, but the other, I think, is the use of a non-linear threshold approach, which is a larger question. I think that I have comments on for 6B, but perhaps we should bring that up here.
Well, if that's okay with the chair.
Do we
want to go to 6B or wait till tomorrow?
Well, it's talked about here, and you raised it, so we got the time, so it's probably a good time to discuss it.
Well, if Dr. David is ready for 6B,
is Dr. David ready?
Sure, I'm ready. I think the concerns that Dr. Babbage has are legitimate, and they are addressed in 6B, or at least partly. So they go together, and if we have time, let's do it.
Yeah, we do. I didn't want to put too many people under the gun. Tomorrow is what I'm really worried about, rather than today. Okay, so let's proceed to 6B then.
Can we finish with 6A and just see if anybody else has other comments, and then go
I'm
to
sorry,
6B?
I thought I did that because Dr. Rowlands raised his hand, but he was actually part of the charge group. So yes, you're correct. Are there any questions from comments from the remaining SACC members? Okay, looks like no. And now EPA, any clarifying questions?
So this is Anthony Les with EPA. We don't have any clarifying questions.
All right, thank you. So now I guess we go to 6B, and if we can get that read in the record.
Sure. Okay. So charge question 6B. Please comment on the strengths and uncertainties of EPA's preliminary cancer classification for DEHP.
All right, let's go to Dr. David.
Okay, so the short answer is that the SACC members agreed with the preliminary cancer classification. There was not consensus about the question of threshold. So let me go through that. So first of all, the cancer assessment for DEHP was consistent with scientific thought regarding the MOA for DEHP-induced hepatocarcinogenesis. But some members felt that the scientific rationale that PPAR alpha activation follows a threshold is well supported, and that other nuclear receptor mediated MOAs such as CAR, RXR, AHR also exhibit threshold behavior and so support the implication for PPAR alpha. And the observation of a non-cancer NOAEL or LOAEL is certainly lower than the lowest threshold for tumorigenesis, whether in the liver, pancreas, or testis. So the dose of the NOAEL for DEHP-induced hepatic cancer is higher, and therefore is not really an issue that that should be driving this assessment. On the other hand, there were those who felt that the dose response really doesn't show evidence of a threshold, because There is a dose response for some of the non-tumor activity that's associated with PPAR alpha, namely the palmitoyl-CoA activation, which is a lipid oxidation, and cell proliferation, both of which appear to be linear and can be extrapolated to or near background rates. So there's no suggestion of a threshold there. Now, that doesn't prove the absence of a threshold, but it certainly doesn't suggest that one exists. Also, with regard to the wording that's used, the implication is that if there were sufficiently high levels of DEHP that humans were exposed to, that they might indeed get cancer. And this is certainly an uncertainty. And it's inconsistent with many experts' opinions regarding the actual mode of action and whether or not humans are susceptible to hepatocarcinogenesis from DEHP. Some members felt that it would be better if the agency could conclude, as a number of other organizations have, or at least scientists have concluded, that the data support that DEHP is not likely to be carcinogenic to humans. With respect to the pancreatic acinar cell tumors and Leydig cell tumors, the experimental evidence clearly indicates that these occur only at high exposure levels and certainly are not consistent across species. There is some uncertainty in this assessment because there is no clear mode of action, and it's not clear that it directly involves PPAR alpha activation. There's suggestion that the CAR receptor is a very reasonable alternative. Also, at high doses, one may see cytotoxicity, which can enhance tumor development in the absence of nuclear receptors. However, in a typical wild-type rodent for this class of chemistry, PPAR alpha agonism is the predominant molecular initiating event that starts the biological cascade that leads to the tumorigenic response in rodents. And this includes pancreatic tumors in that regardless of if the mode of action is well understood or not. Now, there were some additional comments that regarding uterine tumors that were observed in a study, I think it was with butyl-benzyl phthalate. And those comments, I won't necessarily read them all into the record, but I want to make sure that they will be included in the written discussion because it has to do with the relevance to feed restriction and how that impacts the susceptibility to tumors. So in the case of lower caloric intake, there are statistically lower incidences of mammary gland tumors and pituitary tumors, but a higher incidence of uterine tumors for the calorie-restricted animal. So even though that's not part of this particular question, I want to make sure that it gets captured in the document. And I then ask if the other discussants, my colleagues, have any further comments.
Thank you, Dr. David. Let's see, Dr. Wolf?
Yeah, I think it was mostly covered, I think, with the issue of threshold or non-threshold. You really have to look across the entire set of key events, mode of action. And with something like nuclear receptor agonists, they induce enzymes in the liver And you will see, and they may induce them at very low concentrations. That's the only way that a rodent has to get rid of a contaminant that it eats is by metabolizing it away. And that because they can't vomit. So you will see that kind of enzyme induction. You'll see palmitoyl CoAse early and maybe at low concentrations, but that doesn't eliminate the threshold of the other key events, such as atypical hyperplasia and some of the other key events, increased proliferation, the mitogenic response, which is short-term, goes away and then returns later. And so those kinds of things also are very important as part of your collection of key events for the mode of action. So just because some of them might look linear in a standard study, even in vitro, it's the constellation of key events across the entire mode of action that you have to look at. And then that body of evidence suggests that without sufficient agonism, you don't see that. The other thing is PPAR alpha is a common drug target, and there's really no evidence from the pharmaceutical literature that induces tumors in humans.
Thank you. Dr. Martinez?
Hi, I have nothing further to add, and he summarized all my comments. Thank you.
Thank you. Dr. Rowlands?
Nothing further to add. Thank you.
Thank you. And Dr. Gentry?
Nothing further to add. A lot of the extra comments I would have made were made by Dr. Wolf.
Great. Thank you. Now, any comments from the rest of the committee? And I know that Dr. Babich had a comment previously, so let's start there and then we can move forward.
Okay, so what I tried to do is in writing the paper by Clonig et al., I was on the ILSI committee that wrote that. And we did work on the mode of action, but a lot of people wanted to conclude that, okay, this is mode of action. It's not going to happen in humans, but what if it does? Just in case it does, it has to be a threshold because it's non-genotoxic and it binds to a receptor. And so that's what prompted me to explore the dose responses of any of the steps that I could get data on. Did the tumor response, of course, the Pal-CoA oxidase induction, and I did looked at tumors as a function of that. And I also found some data on cellular proliferation. And when I graphed them, they all appeared linear. And you could, in fact, extrapolate the line to somewhere near either the origin or the background level. That doesn't prove it's a linear dose response. But if there were a threshold, you would expect to see either a nonlinear response or something that extrapolates to the x-axis. So I couldn't find any suggestion of a threshold. Now, in the EPA report, they justified assuming a threshold because it's non-genotoxic, and that in itself I don't think is nearly enough. I think you need to look at the mode of action and ask what are the responses of the different steps, or is there something in the mode of action that can justify having a threshold or not. And so if you look at the Clonig paper, there are certain pages on the dose response, and that's where I explain what my thinking is. But you can't just say it's non-genotoxic, therefore it must have a threshold. Also, someone mentioned, Dr. Wolf mentioned that there's no evidence that PPAR alpha agonists cause cancer in humans. That's true. That's true about the study, the statistical strength of those studies. But the point is, humans don't induce peroxisome well, in the rodents, peroxisome proliferation is how they metabolize lipids. In humans, it's a different pathway. So, I mean, I suppose that's one more reason to think that that this MOA is not likely to occur in humans. So that's, I think almost certain I'm in the minority, and in fact, I may be the only one on this call who would question the threshold, but that's my thinking on that.
Thank you for that important contribution. And do you have those graphics that you were mentioning?
I have them, and I could probably want to see if I could find them in a hurry.
We don't need them now. If you think you want to provide them tomorrow, perhaps we can do that.
Okay.
But I was just going to suggest that if you provide your comments in written form and that graphic to Dr. David, he can include it.
Dr. David has my written comments. He summarized them a little bit. And if I haven't already, I will upload the Klonick paper to the SharePoint.
Okay, thank you very much. And I see Dr. Heiger-Bernays has her hand raised.
Right, thank you. I actually have a question for Dr. Babich. In your last statement, mode of action, and I want to make sure I get it, I really get it straight, because we've been talking for 30 years, I think, about PPAR alpha, peroxisome proliferation, humans and rodents. So PPAR alpha does exist, is important in humans. We know that. So mode of action with regard to PPAR alpha is certainly relevant. Are you saying that peroxisome proliferation, I just want to make sure that I'm understanding that are we talking about the molecular events, or are we talking about peroxisome proliferation's relevance in humans? Or are we talking about the molecular events and the biology that occurs in humans?
Well, I think we're talking, most of the discussion is about the animal data.
Right, right.
Now, in humans metabolize lipids differently.
Correct.
So we don't induce Pal-CoA, for example. We induce another set of enzymes. So I think that makes the mode of action in animals less likely to be important in humans.
Okay. And by extension, when you say less likely,
yeah,
are we going to peroxisome proliferation, or I just want to be clear, which is because we've, again, 30 years of this. PPAR alpha is relevant in humans. We can see that with various animal models. PPAR alpha binding and activation, including, and in some cases, including CAR. But my question is, with regard to this question, do the data in your evaluation rule out the involvement of the peroxisome proliferation that is occurring in animals as not being clear? Okay, I have to figure this out.
I mean, in humans, peroxisome proliferation is not going to happen to the same extent as it does in animals. It can happen. I think the conclusion of the Klonick paper and others in other papers published since then is that this is, what causes tumors in the animals is not likely to happen in humans. I mean, it's very not likely. No, I don't think anyone would say absolutely not going to happen.
Okay.
But I think I'm convinced that it's enough that EPA doesn't need to consider at least the liver tumors with regard to human risk assessment.
Okay, so if the evidence is sufficient for EPA not to consider liver tumors that are seen in rodents for humans, then I'm trying to understand the data that support the either involvement of PPAR alpha or something else in the evidence for human carcinogenicity.
Really, all I'm saying is that in humans, fats are metabolized differently. So
yes,
it's a response. The peroxisome proliferators are the animal cells see them as lipids.
Mm-hmm.
But in humans, they induce a different set of enzymes because we metabolize lipids differently.
Okay. All right. Thank you for
helping
me. I'm not yeah, I'm just seeking to understand a little bit more so I can be, I guess, knowledgeable in drafting and responding, and I'm interested in reading the Klonick paper. So thank you.
Okay, well, thank you for listening to my rant.
No, it's not. It's not my rant would no. Nobody wants to hear my rant about PPAR. They don't want to hear my rant. But I'm going to go ahead.
No, it's been going on for too long.
Yes, indeed it has. Don't worry about this. It's PPAR alpha. No, okay. So I want to raise something a little bit different, and I could have raised it in 6A, but I think it's appropriate here because of the classification question, right, of the carcinogenesis. And the point that I would like to at least have in the record is that this threshold-based approach to cancer, just like what has been discussed now for 2 days and however many years, the non-cancer point of departure threshold approach, they're actually both problematic. And I'll hearken back to what you've said and actually what Dr. Rowland says about disease and processes. It assumes that there are no effects, no molecular changes or insignificant changes, including presumed molecular initiating events or key events that occur below the POD or threshold. And this is particularly important for susceptible populations at lower doses. The national academies and others, WHO included, many researchers strongly recommend that harmonization of approaches, cancer and non-cancer, actually adopt a non-threshold approach and not vice versa. And I know that this recommendation has been made on the SACC by the SACC before. And, you know, I think having this discussion about mode of action and molecular events highlights the fact that we're really taking a microscope to a single process as opposed to the multiple processes that are going on in the living organism. And I just want to put that in the record. So thank you.
And I agree with that.
Okay.
All right.
Thank you.
Thank you for that discussion. And Dr. Hager-Bernays, I think you're correct that that dialogue is pretty robust within the SACC and maybe the scientific community. And I hope that EPA's movement towards the NAMS approach gets to those molecular initiating events that hopefully solve some of these problems. Dr. David.
Well, I just wanted to add my 2 cents into this conversation, and I think Dr. Babbage is right that the paper from Jim Klonick that we all worked on is of value, but there are more recent papers that would be of value to look at, and these are by Chris Corton and others. And I think actually the agency is going to be familiar with this because it was discussed as part of the DINP cancer risk evaluation earlier this year, as I remember. Okay, so I think that's when it was. I've forgotten already. Those documents, we can go back to that SACC report and perhaps put in the SharePoint some of those documents from Chris Corton that lay out in perhaps better detail than the Klonick paper why the carcinogenesis via the PPAR alpha activation is not relevant for humans. I mean, there are a whole host of parameters, one of which being the human PPAR alpha is simply not as sensitive to activation as the receptor in a rodent. So, but that's part of it, but there are others. And just wondered if that would be of value to put that information into the SharePoint.
So who are you suggesting would put that in there? Is that the information that
so the SACC that evaluated DINP and DIDP, and this was last year. I've forgotten when.
Yes,
you chaired this, as you recall, and
that's why it's kind of a blur because of that.
And Penny Fendercrisp took on this issue, and I know that she entered a lot of information into the SACC report, and part of that was from the Corton paper, which I believe is even cited in the current document. So it might be worthwhile to look at what the SACC report said as some information pertinent to this.
So I think that it would be relatively simple, even if I do it, just to
sure
put that in the SharePoint file for everybody to see. Yeah, thank you for that comment. Okay, are there other comments from committee members? And by that, I mean committee members and ad hoc members as well. Dr. Gentry.
I was just looking back through my file from that SACC review, and I think there's a couple other papers we could put on the SharePoint. I think there's a whole sample paper, the Clonic was mentioned, the Corton, and there may be one more, but I've got those papers too. If you want me to upload them, George, I'd be glad to around this charge question.
That would be great because I would have to dig those out because I don't think I was well, I know I wasn't a discussant on any of those.
Okay.
Thank you. That's excellent. Dr. Ottinger.
For what it's worth, I uploaded to the charge question 2 and 3 folders that had PDFs of papers, which aren't directly relevant to this charge question, but if people are looking for it and happen to see the references cited under those charge questions, the papers should be in the folder on the SharePoint.
Right. Thank you. Other comments from the committee? If not, let's go to EPA and see if there are clarifying questions.
Thanks, Dr. Cobb. Yeah, I just got a couple of things I want to say to get on the record and then maybe one clarifying question. So in our cancer assessment for the 5 high priority phthalates, specifically for DEHP, we don't independently reevaluate, all of the evidence for a PPAR alpha mode of action for DEHP for those liver tumors, but we do review Chris Corton's 2014 and 2018 publications where he walks through, all of the different lines of evidence supporting a PPAR alpha mode of action, including, all of the modified Bradford Hill criteria. So we summarize all of that information. And I think those publications, the 2014 and 2018 Cornell publications are the ones that Dr. David had raised just a minute or two ago. In addition to walking through that mode of action analysis, we also discuss other potential modes of action, ruling many of them out, as well as some of the remaining sources of scientific uncertainty. Then a couple of committee members also brought up the DINP peer review meeting from last year. I think it was exactly a year ago, actually now. And in that peer review meeting, we'd asked SACC to weigh in on our mode of action analysis for DINP. And in that assessment, we had concluded that the way the scientific evidence supports a non-genotoxic threshold PPAR alpha mode of action for DINP. And that conclusion was strongly supported by the committee, again, for a non-genotoxic threshold mode of action. In addition to that, I think, and maybe it wasn't consensus, but I think the majority of committee members also supported the conclusion that those liver tumors probably weren't human relevant. So that was the DINP assessment. And what I'm hearing, I think, from all of the discussion for DEHP is that maybe and I really just need this clarified in your report. I think this is really, really important. It sounded to me like maybe the majority of committee members or discussants for this charge question agreed with the conclusion that DHP is causing these tumors through a threshold mode of action. And maybe there was 1 or 2 members that were a minority opinion here. So I'm just really hoping that in the report, the report can be really clear about where the majority of the committee was leaning as far as that conclusion went, and if it was what was actually the minority opinion, if that makes sense.
Yeah, I hear what you're saying, and I think I'll go back to Dr. David to see if he can clarify or summarize whether the discussants had a consensus or near consensus, or I know we heard a couple of people speak up that maybe weren't on the charge question because we simply have so many. but I don't know if you have that. And if not, we don't have to have consensus. It's just interesting to know if there were differing opinions there.
Well, there were differing opinions. I mean, I don't have a tally as such, but I can tell you that of the, what did we have? 5 members, 6 members?
You had 5.
So there were at least 2 that felt that there was just a threshold, that was reasonable. And so there were at least 2 that said, no, there's no threshold. So we don't have, unfortunately for EPA, we don't have a majority opinion.
Okay,
Well,
so thank you.
Okay.
Yeah, we can try to have email dialogues and the like, or maybe even a breakout group or 2, but we can't have everybody in the same room at the same time as a breakout group to try to come to some conclusion about that. Some better resolution to how that's split up among the committee.
I mean, some of the folks in the documents will just put a little question to agree or disagree, I agree or I disagree, and you can count the votes. Not everybody made an opinion. Maybe they read it and said, yeah, that's fine. Wasn't. So maybe starting there to see if there's a consensus amongst
I think
those that, and then we can do another one when you do the full document.
Yeah. I think that's
necessary.
I think that's very helpful. Thank you, Doug. And I didn't mean to cut you off. I'm sorry if I did. That was not my intention. No, I think that's very helpful, and that's a good reminder to everybody.
Actually, if you don't mind, what I would prefer to do, I have no problem having people weigh in yay or nay, but it would be worthwhile to put the argument out in a document that people can look at. So basically taking our comments and fleshing them out a little too.
Oh yes. Oh yes. Oh yes. Exactly. All right. And then Dr. Graham, did you have a further comment?
I was just going to suggest that during the final minutes, we have done that before, where we see if there's consensus, see if there's majority. So that was all, and that's basically what Dr. Wolf had said, so.
Good. Thank you very much. I appreciate that. Okay. And back to Dr. Luss, does that answer your question, even though maybe not the way you had hoped?
Yeah, no, this is Anthony Laws with EPA. Yep, that works. Thank you. I appreciate it.
Okay. Excellent. Well, now would like to circle back to the committee and see if there are any comments or clarifying questions that anyone needs to ask based on anything we've talked about today or even yesterday, related to the charge questions so far or the presentations that we saw. Daniel, are you trying to speak?
I can never find the hand raise button. Sorry. Yes, this is Dan Spade. I just want to briefly say that I was the lead discussant on charge question 5D. And one thing about our response that is an outlier relative to the other responses of the SACC is that we did not explicitly recommend, that EPA conduct benchmark dose analysis. I guess I want to say for the record that I'm cognizant of the fact that that seems to be the consensus of the SACC in general, and so we will consider that in our post-meeting response. Does that make sense? Or
It does. It
okay.
does very much. And since I was responding to that, I'll also say that I went on that BMD path for a lot of responses simply because it was a way to demonstrate that some of the lower dose selections could have been made or were supported, not necessarily that it was the only way to go.
Fair.
Dr. Wolf.
Yeah, I'll preface this by apologizing for not being present yesterday, except I had my grandkids here, so there you go. uh, so I wanted some clarification, if possible, from the EPA. They had they had modified the question around metabolic syndrome, and I just wondered, have they thought about how they're going to approach those sections in the documents where it does discuss metabolic syndrome? Have you thought about your approach to doing that? I know you've kind of focused on just hormone changes and metabolism changes, but as opposed to the more generalized metabolic syndrome discussion that was in some of the documents.
Yes, thank you, Dr. Wolf. This is John Halloran, EPA. We'll need to discuss it internally, but my thinking is that what we'll do is remove references in the document when we revise it for the final, where we're discussing metabolic syndrome. And we were using that term to refer kind of to the suite of effects in the animal studies with glucose and insulin homeostasis and lipid metabolism. But we'll retain it when it's mentioned in any publications, like in the epidemiology studies, where it's referring more specifically to the more diagnostic criteria,
right.
Where it's more appropriately specific in that way, if that makes sense. Because we were just trying to think of a term in a way to describe the studies that are looking at that group of parameters and effects.
Well, I think because I brought this up when we had the previous meeting. So I think if you adhere to what you just said, I would be really supportive of that approach.
Okay. All right. Excellent. Thank you for the clarification.
Thank you.
Any other comments from the committee? I actually had one. It's just a comment, and I got this reviewing my notes yesterday, and I forgot. And I don't think it requires any response. But there were mentions yesterday about movement of phthalates to groundwater, and while I recognize that the polarity and the KOCs would kind of indicate that it's going to sorb tightly to organic matter. In areas where there's not much organic matter, you're probably going to have migration to groundwater, and there's certainly phthalate presence in groundwaters in certain highly contaminated areas. So that's just a minor point that that came up, that some of the language could be cleaned up a little bit with a little more specificity in some of those details. Okay, if there are no more clarifying comments or questions, then I'll turn it over to Dr. Camel for closing us out as a DFO, so that some of the discussants can continue writing their responses for the rest of the week.
Well, thank you, Dr. Cobb. It was really a very interesting meeting day today, very interesting discussions. And I want to thank you for chairing and Dr. Gentry for chairing this parts of these sessions. And thanking also the SACC and the ad hoc reviewers for responding to the charge questions, and for EPA also for answering questions and clarifications about the charge, about that the SACC members had. So that said, then we will meet tomorrow at 10 o'clock, and this meeting is adjourned.